Imagine looking up at the night sky and seeing billions of stars twinkling in the vast darkness. It all seems so random, like scattered grains of sand on a cosmic beach. But what if I told you that the universe isn't as chaotic as it looks? That there's a hidden structure, an invisible web stretching across the cosmos, shaping everything we see, including galaxies, stars, and even the space in between? Scientists call these structures cosmic filaments, and they might just hold the key to understanding why the universe looks the way it does. But here's the crazy part: despite their massive influence, we can't even see them directly. They're like the scaffolding of the universe, dictating where galaxies form and where vast empty voids appear. And the deeper we look, the more we realize that these filaments might be doing something even stranger than we ever imagined. At first glance, space looks empty. But in reality, it's crisscrossed by an enormous web of dark matter and gas, filaments stretching for hundreds of millions of light years. They connect galaxy clusters together like highways, guiding matter across the universe. These structures are so large that they make galaxies look like tiny dots in comparison. Scientists only started understanding their true importance recently, and what they found is mind-blowing. Galaxies don't just randomly appear, they form along these filaments, as if drawn there by some invisible force. But how does this work? And why does the universe arrange itself in such a structured way? To answer that, we need to go back to the beginning. Not just a few million years, but all the way back to the Big Bang, when the universe was nothing but a chaotic soup of particles. In those early moments, tiny fluctuations in density appeared. Some areas had a little more matter than others. Over time, gravity pulled more and more material into these dense regions, forming long, thin strands of gas and dark matter. These strands became the filaments we see today. They stretched and connected, forming a web-like structure that shaped the entire universe. But here's where things get interesting. Galaxies, stars, and planets, including Earth, all owe their existence to these filaments. Without them, the universe would be a scattered mess, with matter floating aimlessly. Scientists first suspected the existence of these filaments when they noticed that galaxies weren't randomly distributed. Instead, they appeared to be arranged in patterns, connected like beads on a string. Computer simulations confirmed it. If you map out where galaxies are, they form a giant cosmic web, with filaments acting as the threads that hold everything together. The biggest mystery, though, is what these filaments are actually made of. We know they contain gas, which fuels the birth of new stars, but the real secret lies in dark matter. This invisible, mysterious substance makes up most of the mass in the universe, yet we can't see or touch it. But we know it's there because of its gravitational pull. And it turns out, dark matter is the backbone of these cosmic filaments. It's the glue holding the universe together. But here's the real kicker: filaments don't just shape galaxies, they also dictate how they evolve. Scientists have discovered that galaxies near filaments grow faster, form more stars, and even spin differently than galaxies floating in isolation. It's as if these filaments are feeding them, channeling gas directly into their cores. And that leads to an even bigger question: do filaments decide which galaxies will thrive and which ones will die out? The more we study these structures, the stranger things get. Some scientists believe that cosmic filaments might even influence the movement of the largest objects in the universe. Galaxy clusters, the biggest structures we know, aren't just sitting still. They're moving, drifting along these filaments like cars on an invisible highway. And incredibly, this motion isn't random. It's as if the universe itself has traffic patterns, with filaments acting as the roads guiding everything to its destination. But here's where things get even weirder. Some studies suggest that these filaments might have a role in shaping supermassive black holes. Every large galaxy has one at its center, but scientists have long wondered how they got so massive so quickly. Filaments might be the answer. By funneling gas straight into galaxies, they could be fueling black holes, making them grow at a much faster rate than we ever thought possible. If this is true, then filaments aren't just shaping galaxies, they're shaping the most extreme objects in the universe. And yet, despite all this, we can't see these filaments directly. They're invisible to the human eye, and even to most telescopes. Scientists have to use clever tricks to detect them, like looking at how they bend light from distant galaxies or how they affect the motion of nearby objects. Some recent breakthroughs, though, have allowed us to glimpse these hidden structures for the first time. In 2019, astronomers used a special technique to spot a giant filament stretching across space, lighting up as gas within it collided and heated up. This was the first real evidence that these structures weren't just theoretical, they were real. But if filaments are everywhere, why don't we notice them? The answer comes down to their density. Even though they stretch across hundreds of millions of light years, they contain very little actual matter. If you were floating inside one, you wouldn't see much, just a faint glow from distant galaxies and an almost imperceptible pull of gravity. But despite their ghostly presence, they control the fate of everything in the universe. Scientists are now using massive simulations to recreate the cosmic web in detail. These virtual universes, built inside supercomputers, allow us to see how filaments interact, how they evolve, and how they might even influence the fate of the universe itself. And one of the most shocking discoveries is that filaments might not just be passive structures. They could be actively shaping the very laws of physics as we know them. Some theories suggest that these structures might be influencing dark energy, the mysterious force causing the universe to expand faster and faster. If that's true, then filaments aren't just shaping galaxies. They might be shaping the very fabric of reality itself. And this raises an even bigger question: what happens to these filaments as the universe ages? Right now, the cosmic web is stretching as space expands. But will it eventually break apart? Will filaments become so stretched that they lose their ability to hold galaxies together? Some scientists think this could be the fate of the universe, a slow unraveling of the cosmic web, leading to a future where galaxies drift apart, and the universe becomes a cold, dark, and empty place. But for now, filaments remain one of the most mysterious and important structures in the cosmos. They are the hidden highways of the universe, the invisible architects of galaxies, and possibly even the key to understanding the biggest mysteries of space. And yet, we've only just begun to scratch the surface. What else are these cosmic filaments hiding? Could they reveal secrets about the early universe, the nature of dark matter, or even the fate of the cosmos itself? The deeper we look, the more we realize that these structures might be far more important than we ever imagined. If you think about it, cosmic filaments are like veins in a body, carrying vital material across the universe. Without them, galaxies wouldn't have formed in the way we see today, and the entire structure of the cosmos would look completely different. But what's even more fascinating is that these filaments don't just guide matter, they also seem to be controlling the flow of energy itself. Scientists have discovered that gas within filaments is often much hotter than expected, reaching millions of degrees. This extreme heat suggests that something strange is happening inside these structures. Some researchers believe that as gas falls into the filaments, it gets compressed and heated, creating enormous shockwaves that ripple across the cosmic web. Others think that magnetic fields might be playing a role, influencing how gas moves and even affecting the formation of new stars. And then there's the strangest mystery of all. Why do some filaments seem to be spinning? This discovery, made just a few years ago, turned everything we thought we knew about cosmic structures upside down. Normally, we think of galaxies as the only objects in space that rotate. But scientists have found evidence that entire filaments, stretching across millions of light years, might be spinning like giant, invisible tornadoes. If true, this would be one of the largest known examples of angular momentum in the universe. But how is this even possible? What force could make something so massive start rotating? Some scientists believe that when galaxies fall into a filament, their motion could create a twisting effect, gradually making the entire structure spin over billions of years. Others think that the rotation might be a leftover effect from the very early universe, imprinted onto filaments when the first structures began forming. But whatever the cause, this discovery changes everything. It means that filaments aren't just passive structures. They're dynamic, active, and possibly even influencing the motion of entire galaxies in ways we never expected. And this brings up another big question: how do filaments evolve over time? Right now, the cosmic web is growing and changing as the universe expands. But what happens in the distant future? Will filaments continue to stretch and shape galaxies, or will they eventually break apart? Some scientists believe that as dark energy continues to accelerate the expansion of the universe, filaments might start thinning out, losing their ability to connect galaxy clusters. If this happens, the cosmic web could slowly unravel, leading to a universe where galaxies become isolated, drifting apart forever. But there's also a more extreme possibility. Some theories suggest that filaments could eventually collapse under their own gravity, triggering massive cosmic events like galaxy mergers or even the formation of new black holes. If this is true, then filaments might not just be shaping the universe, they could be setting the stage for its future. And here's where things get really strange. Some scientists believe that cosmic filaments could be connected to even deeper mysteries, like the true nature of dark matter. We know that filaments contain dark matter, but what if they also hold clues about what dark matter actually is? Right now, we have no idea what this mysterious substance is made of. But if filaments act as cosmic highways for dark matter, studying them could give us the first real clues about this invisible force shaping the universe. And then there's an even wilder theory. What if filaments are actually linked to the hidden structure of spacetime itself? Some physicists have proposed that filaments might not just be made of dark matter and gas, but something even stranger, hints of hidden dimensions or even evidence of a deeper, underlying structure to reality. If this is true, then filaments aren't just shaping galaxies. They could be the key to unlocking the deepest secrets of the universe. But for now, one thing is clear: filaments are far more important than we ever realized. They are the invisible threads weaving the cosmos together, the hidden forces shaping galaxies, and possibly even the key to understanding the fate of the universe itself. And as scientists continue to study these structures, we might just uncover some of the biggest secrets in the cosmos. The more we learn about cosmic filaments, the more they challenge our understanding of how the universe truly works. For decades, we thought of space as mostly empty, with galaxies scattered randomly throughout. But filaments reveal a hidden order, a structure so vast and complex that it's hard to wrap our minds around. They are the highways along which galaxies move, the scaffolding that holds everything together. And what's even crazier? These filaments are so massive that they dwarf even the largest galaxies we know of. Some filaments stretch for hundreds of millions of light years, making them the largest known structures in the universe. Yet, despite their size, they are almost invisible. If you looked up at the night sky, you wouldn't see them. They don't emit their own light. Instead, they exist as faint, ghostly structures, only detectable through indirect observations, through the way they bend light, the way they affect the movement of galaxies, and the way they shape the cosmic microwave background. But how exactly did scientists even discover these structures in the first place? The answer lies in the way galaxies are distributed. In the 1980s and 1990s, astronomers began mapping the positions of galaxies on a large scale. What they found was shocking. Galaxies weren't scattered randomly at all. Instead, they seemed to be arranged in vast, interconnected patterns, forming long, thread-like structures that stretched across space. At the intersections of these threads, massive galaxy clusters sat like knots in a web. And in between? Almost nothing. This was one of the first hints that the universe wasn't just a random collection of galaxies but a structured, organized system. And as scientists studied these patterns more closely, they realized that the filaments weren't just random structures. They were fundamental to galaxy formation itself. But how do filaments actually shape galaxies? The answer lies in gravity. Filaments act like cosmic rivers, channeling gas, dust, and even entire galaxies into their paths. As material flows along these filaments, it gets pulled toward denser regions, places where galaxy clusters form. This process plays a huge role in determining which galaxies grow larger and which ones remain small. In fact, some of the biggest galaxies in the universe, the ones sitting in the centers of massive clusters, owe their size to these filaments. Over billions of years, these galaxies have pulled in enormous amounts of gas and other galaxies, all funneled along these hidden structures. Without filaments guiding this process, galaxies would be much smaller, and the universe would look completely different. But there's another side to this story. Filaments don't just help galaxies grow, They also influence what kind of galaxies form. Studies have shown that galaxies inside filaments tend to have different properties than those outside of them. For example, galaxies in filaments often have more gas, which means they can form new stars at a faster rate. Some scientists even think that filaments might trigger star formation directly by compressing gas clouds and causing them to collapse under their own gravity. And then there's the role of dark matter. Scientists now believe that filaments are made up mostly of dark matter, the mysterious substance that makes up about 85% of the matter in the universe. Dark matter doesn't interact with light, so we can't see it directly. But we can see its effects. And when astronomers map out where dark matter is likely to be, they find that it follows the same patterns as the cosmic filaments. This suggests that dark matter isn't just part of filaments, it's actually what's holding them together. In other words, filaments are shaped by dark matter, and in turn, they shape galaxies. This means that if we ever want to truly understand dark matter, we need to study filaments in more detail. And scientists are already working on this. Some of the most advanced telescopes in the world, like the James Webb Space Telescope, are now being used to probe the structure of filaments in ways we've never been able to before. One technique scientists use is called gravitational lensing. This is when the gravity of a massive object, like a galaxy or a filament, bends the light from objects behind it. By studying how this light bends, scientists can map out where dark matter is hiding. And what they've found is incredible. Filaments don't just contain dark matter, they seem to be made almost entirely of it. This means that by studying filaments, we might finally get closer to solving one of the biggest mysteries in physics, what dark matter actually is. But there's another mystery that's just as mind-blowing. Scientists have recently discovered that some filaments aren't just sitting still, they're moving. And not just moving, but spinning. This is a shocking discovery because up until now, we thought that only galaxies and galaxy clusters could rotate. But now, we're seeing evidence that entire filaments, structures spanning hundreds of millions of light years, are rotating like giant cosmic tornadoes. If this is true, it could change everything we know about how the universe works. It suggests that rotation isn't just something that happens on small scales, like planets and stars. It might be a fundamental property of the entire cosmos. But how do you even get something that big to start spinning in the first place? Scientists still don't know for sure, but one idea is that when galaxies fall into a filament, their motion could create a twisting effect that slowly builds up over billions of years. Another idea is that this spin was imprinted on filaments from the very beginning of the universe, left over from the chaotic turbulence of the Big Bang itself. And if filaments are spinning, it raises an even bigger question. What else in the universe is rotating that we don't know about yet? Could entire galaxy clusters be spinning? Could the cosmic web itself have some kind of rotation that we haven't discovered yet? If so, it could mean that angular momentum, the tendency of objects to keep spinning, plays an even bigger role in shaping the universe than we ever thought. But the mysteries don't stop there. Some scientists believe that cosmic filaments might actually be hiding something even stranger. Hints of hidden dimensions or even clues about the fundamental nature of spacetime itself. There are theories in physics that suggest our universe might have extra dimensions beyond the three we see. These dimensions would be invisible to us, but they could still have effects on large-scale cosmic structures like filaments. If this is true, then filaments might not just be highways for galaxies. They could be revealing the deeper structure of reality itself. Some scientists even think that the way filaments connect galaxy clusters might be linked to quantum mechanics, the strange rules that govern particles on the smallest scales. Could it be that filaments are actually shaped by quantum effects on a cosmic scale? Right now, we don't have the answers. But one thing is clear, filaments are far more important than we ever realized. They are the hidden framework of the universe, the invisible forces guiding the formation of galaxies, and possibly even the key to understanding the deepest mysteries of physics. And as our technology improves, we're only going to learn more. Future telescopes, more powerful simulations, and new discoveries in physics could finally reveal the true nature of these mysterious structures. And when that happens, we might just unlock secrets about the universe that are even more mind-blowing than we ever imagined. The more we uncover about cosmic filaments, the clearer it becomes that they are not just passive structures. They are active players in the evolution of the universe. Their role goes far beyond simply acting as a scaffold for galaxies. They dictate the flow of matter, influence the growth of cosmic structures, and may even be hiding some of the deepest secrets of physics. One of the most fascinating aspects of filaments is how they regulate the movement of galaxies. Imagine a vast cosmic river system, with filaments acting as the channels that direct the flow of material. Galaxies don't just randomly drift through space. They follow these filaments, almost like planets following orbital paths, except on a scale that defies comprehension. The gravitational pull of the filaments ensures that galaxies continue moving along these invisible highways, slowly converging toward denser regions where galaxy clusters form. But the real question is, what is happening within these filaments themselves? They aren't just made of galaxies. They contain vast amounts of intergalactic gas, dark matter, and even shock waves that heat the surrounding space to extreme temperatures. Some of the hottest regions in the universe are found within these filaments, where gas is compressed and heated to millions of degrees. Scientists have only recently begun detecting these hot gaseous regions, using powerful X-ray telescopes like ESA's XMM Newton and NASA's Chandra Observatory. What they've found is astonishing. These filaments are not just guiding galaxies, they are shaping the cosmic environment itself. And that raises another mystery. If filaments are filled with hot gas, could they be fueling the growth of supermassive black holes? We know that black holes at the centers of galaxies require a constant supply of material to keep growing. Could cosmic filaments be acting as pipelines, delivering a steady stream of gas directly into the hungry mouths of these behemoths? Some scientists believe this might explain why certain galaxies have supermassive black holes that are billions of times the mass of our Sun. Perhaps they are located in regions where filaments are funneling an unusually large amount of material toward them. This could also explain another puzzle. Why do some galaxies seem to shut down their star formation while others remain active for billions of years? The presence of filaments might determine which galaxies get a continuous supply of gas and which ones are cut off. If a galaxy remains connected to a filament, it can keep pulling in fresh material, forming new stars for an incredibly long time. But if it gets separated from the filament, its supply of star-forming gas might be cut off, causing it to become a dead, barren galaxy much earlier than expected. But here's where things get even stranger. Some recent studies suggest that cosmic filaments might not just be shaping galaxies. They might be influencing their rotation as well. This is where things start to challenge our entire understanding of how galaxies evolve. For decades, we thought that a galaxy's spin was mostly determined by the conditions of the gas cloud from which it formed. But new research suggests that galaxies connected to filaments tend to have their rotation axes aligned in specific ways. This means that filaments might not just be feeding galaxies. They might be guiding their very movement in a way we never anticipated. What could be causing this? One theory is that as matter flows along a filament, it carries a subtle angular momentum with it. Over billions of years, this rotational influence could be transferred to galaxies, affecting the way they spin. But if this is true, it forces us to rethink our entire model of galaxy formation. It means that the shape and spin of galaxies aren't just determined by local factors, but by the vast, unseen cosmic structures they are embedded within. And this brings us to another fundamental mystery. If filaments are influencing the way galaxies rotate, could they also be influencing the rotation of entire galaxy clusters? Could we be looking at an even larger cosmic pattern of movement, one that extends beyond galaxies to the largest structures in existence? Some astronomers think the answer might be yes. If filaments have inherent spin, then galaxy clusters at their intersections might also be slowly rotating as a result. This could mean that the entire large-scale structure of the universe isn't just a static web, it's a dynamic, moving, twisting entity that we are only beginning to understand. But here's the craziest part. Some scientists are now questioning whether this cosmic rotation might be linked to something even deeper, something fundamental about the universe itself. Could the very fabric of space-time have an inherent twist to it? Could the cosmic web's motion be a faint echo of the way the universe was set into motion at the very beginning, possibly even hinting at unknown physics beyond what we currently understand? Some theories suggest that the large-scale rotation of the universe could be linked to primordial fluctuations in spacetime, tiny ripples left over from the Big Bang that set the entire cosmic web into motion billions of years ago. If this is true, it would mean that filaments aren't just the result of gravitational evolution, they are a direct imprint of the earliest moments of the universe itself. And this leads to an even more mind-bending idea. If filaments are carrying angular momentum across the cosmos, could they be revealing something about the nature of dark energy, the mysterious force that is accelerating the expansion of the universe? Right now, we have almost no understanding of what dark energy actually is. We only know that it exists because we see its effects. But if filaments are moving and spinning in ways we don't yet fully understand, they might be the key to unlocking this mystery. One possibility is that dark energy isn't just a uniform force pushing everything apart. Instead, it could be interacting with cosmic structures in complex ways that we haven't yet detected. It could be amplifying the motion of filaments, or even causing them to evolve in ways we don't yet understand. If this turns out to be true, studying filaments could give us a way to probe dark energy directly, finally revealing what it is and why it exists. And if that happens, it could change everything. It could mean that the ultimate fate of the universe, whether it keeps expanding forever, collapses back in on itself, or even cycles through endless cosmic rebirths, might be hidden in the way these filaments move. Right now, we are only scratching the surface of what filaments can teach us. Every new discovery raises more questions than it answers. But one thing is certain, these structures are far more than just the framework of the universe. They are the hidden engines driving the evolution of galaxies, shaping the fate of cosmic structures, and possibly even revealing the fundamental nature of spacetime itself. And as we continue to study them, we may find that they hold the key to answering some of the biggest mysteries of all: how the universe was born, how it will evolve, and what its ultimate destiny will be. If cosmic filaments are truly influencing everything from galaxy formation to the large-scale motion of the universe itself, then we have to ask, what else are they hiding? Could they be harboring forces or particles that we haven't even discovered yet? Some scientists speculate that filaments might play a role in one of the biggest unsolved mysteries in physics: dark matter. We know that dark matter is responsible for most of the gravitational structure in the universe, yet we have never directly detected it. It doesn't emit, absorb, or reflect light, making it completely invisible. But we do see its effects. It keeps galaxies from flying apart, it shapes the cosmic web, and it appears to be the dominant form of mass in the universe. The problem is, we still don't know what it is. One hypothesis is that filaments could act as reservoirs of dark matter, trapping it in ways that make it more concentrated than we previously thought. This would explain why galaxies and clusters tend to form where filaments intersect. These regions would be rich in dark matter, providing the gravitational pull needed to bring ordinary matter together. But what's even stranger is that some studies suggest filaments themselves could be mostly made of dark matter, with only a thin layer of ordinary gas surrounding them. If this is true, then filaments aren't just shaping galaxies. They might be the key to unlocking the true nature of dark matter itself. By studying how matter moves along filaments, scientists hope to detect the subtle gravitational effects of dark matter, which could help us determine what kind of particle it is. Could dark matter be something exotic, like a new type of undiscovered particle? Or could it be something even more bizarre, like a hidden property of spacetime that we don't yet understand? There's also another possibility that's even more mind-blowing. Some physicists think that dark matter might not be made of particles at all. It could be the result of hidden dimensions. According to some versions of string theory, the universe might have extra dimensions that are invisible to us, but their effects could still be felt through gravity. If this is true, then cosmic filaments might be revealing the influence of these hidden dimensions, acting as the places where gravity from higher dimensions spills into our own. Imagine for a moment that what we see as filaments are actually the edges of a much larger structure that exists beyond our perception. Could it be that filaments aren't just shaping the universe, but are actually windows into a deeper reality? Some scientists speculate that the way filaments guide the movement of galaxies could be the result of interactions with unseen forces operating in dimensions we can't directly observe. If this turns out to be true, then studying filaments might be our best shot at proving that extra dimensions exist. But here's where things get even weirder. Some recent observations suggest that filaments might not just be passive structures. They could be moving, twisting, and even oscillating in ways that we never expected. If filaments are truly dynamic, then this raises an even bigger question: what is making them move? Gravity alone shouldn't be able to create this kind of large-scale motion. Some researchers think that this could be evidence of an unknown force at work, one that operates on cosmic scales and has never been detected before. And this leads us to another mind-boggling idea. If filaments are interacting with dark matter and possibly even higher dimensions, could they also be influencing the flow of time itself? This might sound like science fiction, but some physicists have proposed that the large-scale structure of the universe could be affecting the passage of time in subtle ways. If filaments are regions of intense gravitational influence, then they might be distorting space-time more than we realize. This could have profound implications for our understanding of time. Could it be that the universe doesn't experience time in a uniform way? If filaments have different gravitational properties than the empty voids between them, then time could be moving at slightly different rates in different parts of the cosmic web. This would mean that the structure of the universe isn't just shaping space, it's shaping time itself. And if that's the case, then what does this mean for the ultimate fate of the universe? If time is flowing differently in different regions, then could certain parts of the cosmos be aging faster or slower than others? Could filaments be acting as cosmic clocks, marking the passage of time in ways we don't yet understand? Some scientists think that this could provide a clue about how the universe might end, whether it will keep expanding forever, collapse in on itself, or transition into something entirely new. Right now, we are only beginning to grasp the true significance of cosmic filaments. They are the skeleton of the universe, the highways of galactic evolution, the potential reservoirs of dark matter, and possibly even gateways to deeper physics that we have yet to uncover. Every new discovery raises more questions than it answers, but one thing is clear: the cosmic web is far more complex, dynamic, and mysterious than we ever imagined. And as we continue to study it, we may find that filaments hold the answers to the deepest questions of all: where we came from, what the universe is made of, and what its ultimate destiny will be. If cosmic filaments are truly influencing time, then this raises an even more unsettling question: could they also be shaping our perception of reality in ways we haven't yet realized? If time flows differently within filaments compared to the vast cosmic voids, then could galaxies within these structures be experiencing the universe at a slightly different pace? What if, from their perspective, entire regions of space outside the filaments seem to be moving in slow motion, or even accelerating? This idea isn't as far-fetched as it sounds. We already know that gravity can warp time. This is a fundamental principle of Einstein's theory of relativity. Clocks on Earth, for example, tick at a slightly different rate than clocks on a satellite in orbit because of the differences in gravitational pull. Now imagine this effect on a cosmic scale. If filaments are massive enough to exert a strong gravitational influence, then could they also be altering the flow of time for galaxies within them? This could have profound implications for our understanding of cosmic history. It might mean that galaxies within filaments evolved at a different rate than those in empty space. If this is true, then what we think of as a universal timeline might not be as universal as we assume. This could even explain some of the discrepancies we see in galaxy formation, why some galaxies appear much older than they should be, while others seem to have formed unusually fast. But here's where things get even stranger. If filaments can distort time, could they also be influencing other fundamental forces of the universe? Could they be subtly altering the way matter interacts with itself? Some researchers think this could be a real possibility. There's already evidence that filaments contain powerful magnetic fields, and some studies suggest that these fields might be shaping the very structure of the galaxies within them. Magnetic fields are one of the least understood aspects of cosmic evolution. We know they exist, and we know they play a role in shaping galaxies, but we don't fully understand how they formed or why they are so strong in some regions and weak in others. If filaments are amplifying magnetic fields, then they might be playing a far bigger role in galaxy formation than we ever realized. And this brings us to another mystery. Are filaments responsible for triggering star formation in galaxies? We know that galaxies within filaments tend to have higher rates of star formation than those in empty space, but we don't fully understand why. Some scientists believe that gas and dust are funneled along filaments, providing a steady supply of raw material for new stars to form. But others think there might be a deeper reason, one that involves the fundamental physics of the universe itself. Some researchers have proposed that filaments could act as cosmic accelerators, funneling energy into galaxies in ways that promote star formation. This could be tied to dark energy, the mysterious force that is driving the expansion of the universe. If dark energy interacts with filaments in unexpected ways, then it could be influencing not just the movement of galaxies, but also their ability to form stars. This raises an even bigger question. Could filaments be acting as conduits for an unknown cosmic force? If so, then what is this force? Could it be something related to dark matter, or is it something entirely different, something we haven't even theorized yet? Some scientists have proposed that filaments might be linked to the early structure of the universe in ways we don't yet understand. According to this idea, the filaments we see today might be remnants of quantum fluctuations that existed in the earliest moments of the universe. These fluctuations, which occurred in the first fractions of a second after the Big Bang, could have laid the foundation for the large-scale structure of the cosmos. If this is true, then filaments might be one of the oldest structures in existence, predating even the formation of galaxies themselves. This could explain why they seem to have such a profound influence on the universe. They were there from the very beginning, shaping everything that came after. And if filaments are relics of the universe's birth, then could they also hold clues about how the universe will end? If they are responsible for guiding the motion of galaxies, then what happens when they eventually shift or collapse? Could filaments be setting the stage for a cosmic transformation that we can't yet comprehend? One possibility is that filaments could eventually unravel, causing galaxies to drift apart and the universe to expand into an increasingly empty void. This would be consistent with the idea of a heat death, where the universe eventually becomes cold, dark, and lifeless. But another possibility is far more dramatic. What if filaments are slowly pulling the universe into a new state of existence? Some physicists think that dark energy might not be a constant force, but something that changes over time. If this is true, then filaments could be acting as the wires that carry this changing force throughout the cosmos. If dark energy were to suddenly shift in intensity, then filaments could amplify this change, leading to a rapid restructuring of the universe itself. This could mean that we are living in a transitional phase of cosmic history, one where filaments are guiding the universe toward a future that we can't yet predict. Could they be leading to a sudden collapse, where the universe contracts in on itself? Or could they be steering us toward a phase transition, where the very laws of physics change in an instant? Right now, we have more questions than answers. But one thing is certain, cosmic filaments are not just passive structures. They are dynamic, mysterious, and possibly even the key to understanding the deepest secrets of the universe. And as our technology improves and our ability to study them grows, we may finally uncover the truth about these hidden giants of the cosmos. What we find could change everything we think we know about the universe, our place within it, and the forces that shape reality itself. If cosmic filaments are actively influencing the large-scale structure of the universe, guiding galaxies, shaping the flow of matter, and possibly even distorting time itself, then we have to ask, what else could they be capable of? Could they be responsible for some of the biggest cosmic mysteries that still puzzle astronomers today? Could they explain why galaxies rotate the way they do, why the expansion of the universe seems to be accelerating, or even why some regions of space appear to have completely different physical properties than others? One of the strangest observations in modern cosmology is the so-called cold spot in the cosmic microwave background, the leftover radiation from the Big Bang. This region of space is significantly colder than the surrounding areas, and scientists have struggled to explain why. Some researchers have suggested that this cold spot might be the remnant of a massive cosmic void, a region of space that lacks galaxies and matter. But what if filaments are involved in this anomaly? Could they be funneling matter away from certain regions, creating these vast, empty spaces that seem to defy the expected distribution of galaxies? This would mean that filaments are not just shaping the places where galaxies form, but also the places where they don't. If filaments are pulling matter along their structures, then they might also be draining certain areas of the universe, leaving behind vast cosmic deserts that we perceive as voids. And if that's the case, then these voids might not be empty at all. They might be the remnants of a process we don't yet understand, one where filaments are redistributing the very fabric of the cosmos. But what if filaments are doing something even stranger? What if they are acting as cosmic accelerators, influencing not just the movement of galaxies, but the fundamental forces of the universe? Some theories suggest that the distribution of matter in the universe is not random, but rather the result of deeper physical principles, ones that involve unknown interactions between dark matter, dark energy, and possibly even exotic particles we haven't discovered yet. Could filaments be the key to understanding these hidden forces? Could they be acting as conduits for an unknown form of energy, one that is responsible for the strange, unexplained behaviors we see on cosmic scales? Some researchers have proposed that filaments might be interacting with dark energy in ways that we haven't yet realized. Dark energy is the mysterious force that is driving the accelerated expansion of the universe, but we don't fully understand how it works or where it comes from. What if filaments are amplifying this expansion, guiding the flow of dark energy just as they guide the flow of matter? If this is true, then it could mean that filaments are not just passive structures, but active participants in the fate of the universe. They could be steering the universe toward an ultimate conclusion, shaping not just the formation of galaxies, but the very destiny of all existence. And this raises an even more unsettling question. If filaments are guiding the universe, then what guided the filaments? Did they form naturally from the distribution of matter after the Big Bang, or is there something deeper at play? Could there be an underlying pattern to the way filaments are arranged, something that suggests an order beyond what we currently understand? Some scientists have speculated that the cosmic web might contain hints of a deeper mathematical structure, one that could reveal fundamental truths about the nature of reality itself. The way filaments connect, the way they guide galaxies, and even the way they seem to influence the passage of time, all of this might be part of a larger framework that we have yet to decipher. Could filaments be revealing the blueprint of the universe, a hidden code that governs the formation and evolution of everything we see? If so, then understanding them might be the key to unlocking some of the deepest questions in physics, from the nature of dark matter to the ultimate fate of the cosmos. Right now, we are only beginning to scratch the surface of what filaments might be capable of. Every new discovery about these vast structures raises more questions than it answers, and the more we learn, the more mysterious they seem to become. But one thing is clear: cosmic filaments are not just passive highways of matter. They are dynamic, powerful, and possibly the key to understanding the hidden forces that shape our universe. And as our technology improves and we continue to map the cosmic web in greater detail, we may one day uncover the true nature of these cosmic giants. What we find could change everything we thought we knew about the universe, and about our place within it. If filaments are truly the architects of cosmic structure, then what does this say about the forces that govern them? The more we study these massive strands of matter, the more it becomes clear that they are not just passive scaffolding but active components in shaping the universe. Could it be that filaments are exerting influence in ways we haven't yet detected? Could they be playing a hidden role in some of the biggest cosmic mysteries we have yet to solve? Take, for example, the distribution of dark matter. We know that dark matter does not emit, absorb, or reflect light, making it impossible to see directly. Yet, its gravitational effects are undeniable. It holds galaxies together and influences their motion. But here's where things get interesting. Dark matter is not evenly spread throughout the universe. It tends to cluster along cosmic filaments, following the same patterns that ordinary matter does. This is strange because dark matter is supposed to interact with regular matter only through gravity. So why is it aligning itself so perfectly with the structure of filaments? Could it be that filaments are acting as something more than just gravitational highways? Could they be concentrating dark matter in ways we don't yet understand? Some scientists speculate that filaments might be amplifying the effects of dark matter, possibly through an unknown interaction that enhances its gravitational pull. If this is true, then filaments could be acting as cosmic amplifiers, making dark matter more influential than it otherwise would be. This could explain why galaxies behave as if they contain much more dark matter than they should. It might not be evenly spread, but instead concentrated along the hidden highways of the cosmic web. And then there's the question of how filaments themselves formed in the first place. We assume that they emerged naturally as the universe expanded, with matter flowing into the densest regions due to gravity. But is it really that simple? What if filaments have been guiding the universe's structure since the very beginning? What if they existed in some form even before the first galaxies formed? There are theories that suggest filaments might have roots in the quantum fluctuations that occurred during the first moments after the Big Bang. These tiny variations in density could have been stretched out by cosmic inflation, forming the foundation of the cosmic web we see today. If this is true, then filaments are not just structures that emerged over time. They could be the oldest, most fundamental structures in the entire universe. But what if there's more to it than that? What if filaments are not just shaped by the past but also influencing the future? If filaments are playing a role in shaping the motion of galaxies, then they could also be determining how the universe evolves over time. Could they be steering the universe toward a specific fate? One of the most mysterious aspects of cosmic filaments is their connection to dark energy. We know that dark energy is causing the universe to expand at an accelerating rate, but we don't fully understand how it works. Some researchers believe that filaments might be interacting with dark energy in ways that are not yet fully understood. If filaments are amplifying dark energy, then they could be accelerating the expansion of the universe even more than we realize. This could have profound implications for the ultimate fate of the cosmos. If the acceleration continues unchecked, then the universe could end in a big rip, where even the structures of galaxies themselves are torn apart. But what if filaments are doing something even stranger? What if they are acting as conduits for an unknown force, something that we haven't yet detected? There are some theories that suggest the structure of the universe might be influenced by hidden dimensions, ones that we cannot see but which still exert an effect on the world we observe. Could filaments be interacting with these hidden dimensions in some way? Could they be serving as bridges between different layers of reality? This might sound like science fiction, but it's not entirely out of the realm of possibility. Some versions of string theory propose that extra dimensions exist, and that they might influence the behavior of matter and energy in ways we haven't yet realized. If filaments are interacting with these dimensions, then they could be influencing the universe in ways that go beyond our current understanding of physics. And if that's the case, then what else might they be capable of? Could filaments be guiding the flow of energy across the cosmos, acting as unseen channels that shape the distribution of galaxies? Could they be responsible for anomalies we haven't yet explained, like the strange alignments of certain galaxy clusters or the unexpected patterns in cosmic radiation? The deeper we look into the nature of filaments, the more questions arise. And the more questions we ask, the more it becomes clear that these structures are not just passive features of the universe. They are active participants in its evolution. And yet, despite all our advances in astronomy, we have only just begun to understand the full scope of their influence. With new telescopes and more powerful simulations, we may soon uncover the true nature of these cosmic highways. What we find could reshape everything we think we know about the universe, about its past, its present, and its ultimate fate. But one thing is certain: the filaments that stretch across the cosmos are more than just threads of matter. They are the hidden architects of everything we see, shaping galaxies, guiding the flow of dark matter, and possibly even steering the universe itself toward a future we cannot yet comprehend. If filaments are indeed influencing the structure of the universe, shaping the motion of galaxies, and possibly even playing a role in the expansion of the cosmos, then we have to ask, what else might they be affecting? Could their gravitational pull be subtly warping space-time in ways we haven't yet detected? Could they be distorting the very fabric of reality itself? One of the strangest ideas in modern physics is that space-time is not a static, unchanging backdrop, but a dynamic, flexible medium that can be bent, twisted, and stretched by the distribution of mass and energy. We see this effect on a small scale with gravitational lensing, where the light from distant galaxies is bent around massive objects, creating eerie, warped images in the sky. But what if this effect is happening on a much larger scale, across the entire cosmic web? If filaments are massive enough, their gravity could be bending light in ways we haven't fully accounted for, subtly shifting the apparent positions of galaxies and distorting our view of the universe. This could mean that some of the structures we see in deep space might not be exactly where we think they are. Could filaments be creating massive, invisible lenses that shape our perception of the cosmos? This raises an even more intriguing question: could filaments be acting as gravitational waveguides? We know that when massive objects like black holes collide, they send ripples through spacetime in the form of gravitational waves. But what happens when these waves pass through a filament? Could the structure of the cosmic web be guiding and amplifying these waves, much like an optical fiber channels light? If this is happening, then filaments might not just be shaping the large-scale structure of the universe. They might also be acting as conduits for information, carrying signals across vast cosmic distances. Could filaments be encoding some hidden information about the early universe, preserving the echoes of ancient cosmic events? And if filaments are guiding the flow of gravitational waves, then could they also be influencing the very laws of physics themselves? Some physicists have suggested that the fundamental constants of nature, things like the strength of gravity, the speed of light, and the charge of the electron, might not be the same everywhere in the universe. In some regions, these values might be slightly different, leading to subtle variations in the way matter behaves. Could filaments be responsible for these variations? Could they be creating pockets of space where the laws of physics operate just a little bit differently than they do elsewhere? If so, then the universe might be far stranger than we ever imagined, a vast, interconnected web where the very nature of reality shifts and warps depending on where you are. This might sound like pure speculation, but there is already some evidence that the structure of the universe is not entirely uniform. Observations of distant quasars have suggested that the fine structure constant, a fundamental number that governs the strength of electromagnetic interactions, might be slightly different in different parts of the cosmos. If this is true, then something must be causing these variations. Could it be the influence of filaments? If filaments are shaping the very fabric of reality, then what does this mean for the ultimate fate of the universe? Could they be guiding the cosmos toward a particular end, an outcome that is predetermined by the way these vast structures are arranged? One possibility is that filaments are acting as cosmic funnels, directing matter and energy towards certain regions of space while draining it away from others. Over billions of years, this could create a situation where some parts of the universe become incredibly dense, while others become almost completely empty. Could this process eventually lead to a final, cosmic collapse? If filaments continue to pull matter along their structures, could they eventually bring everything back together, reversing the expansion of the universe and triggering a new big crunch? Or could they be accelerating the expansion instead, stretching space-time to the point where galaxies become so isolated that they can no longer communicate with each other, leading to the so-called heat death of the cosmos? And if filaments are shaping the fate of the universe, then could they also be influencing its past? Some theories suggest that time itself might be an emergent property of the structure of space-time, meaning that the way matter is arranged could have an effect on the way time flows. If this is true, then filaments might not just be shaping the universe spatially, they could also be shaping it temporally. Could filaments be responsible for some of the strange anomalies we see in the flow of time on cosmic scales? Could they be creating regions where time moves at different rates, subtly distorting the way we perceive the history of the universe? The deeper we look into the nature of filaments, the more it seems like they are not just ordinary structures. They are something far more fundamental, something that might be woven into the very essence of the cosmos itself. They could be the key to understanding not just how the universe formed, but why it is the way it is. And if we can unlock their secrets, we might finally answer some of the biggest questions in physics. Questions about the nature of dark matter, dark energy, gravity, and even time itself. But for now, filaments remain one of the greatest mysteries of the universe. A hidden force that shapes everything we see, yet still refuses to fully reveal its secrets. If cosmic filaments truly hold the key to understanding the large-scale structure of the universe, then what else might they be hiding? These immense, invisible highways of matter stretch across billions of light years, but they are not just passive structures. They are active, evolving, and possibly even influencing forces we barely understand. Could it be that filaments are not just shaping galaxies, but also playing a role in cosmic events that seem unrelated at first glance? One of the biggest unsolved mysteries in cosmology is the distribution of high-energy cosmic rays. These incredibly fast-moving particles travel across the universe at nearly the speed of light, but their origins remain unclear. Some scientists believe they are ejected from supernovae or active galactic nuclei, but others suspect that filaments themselves might be responsible for their strange, scattered paths. If filaments are acting as gravitational highways for galaxies, could they also be channeling cosmic rays, guiding them along invisible paths that crisscross the universe? There's even speculation that filaments might be accelerating these particles, acting as vast, cosmic particle accelerators that energize matter in ways we've never observed before. And if filaments can influence cosmic rays, then what about magnetism? Magnetic fields are found throughout the universe, but their origins are poorly understood. Scientists have detected massive, intergalactic magnetic fields stretching between galaxy clusters, and these fields appear to follow the structure of cosmic filaments. Could filaments themselves be responsible for generating and amplifying these magnetic fields? If so, this could change everything we know about magnetism on cosmic scales. These intergalactic magnetic fields are weak, but they extend across millions of light years, meaning they could have a profound impact on the way matter moves and interacts in deep space. Some researchers even believe that cosmic magnetism might be influencing the formation of stars and galaxies in ways we haven't yet realized. And then there's the question of black holes. We tend to think of black holes as isolated objects, sitting at the centers of galaxies or roaming the universe alone. But what if filaments are connected to black hole formation? Could they be guiding the motion of rogue black holes, acting as cosmic rivers that funnel these dark behemoths into specific regions of space? There's some evidence to suggest that supermassive black holes, the giants that sit at the centers of galaxies, may have grown larger than expected because of their location within filaments. If filaments are providing a steady flow of matter to these black holes, then they could be playing an unseen role in the growth of some of the most powerful objects in the universe. And if filaments are guiding black holes, could they also be influencing another strange cosmic phenomenon, fast radio bursts? These mysterious flashes of energy last only milliseconds but release as much power as entire galaxies. Scientists still don't know exactly what causes them, but some theories suggest they may be linked to magnetars, highly magnetized neutron stars. But what if filaments are playing a role in directing these bursts? Some studies suggest that fast radio bursts might be more common in regions where filaments are particularly dense. Could these cosmic threads be acting as conduits for energy, guiding the flow of fast radio bursts in ways we don't yet understand? And if filaments can influence radio waves, could they also be affecting another strange phenomenon, the cosmic microwave background radiation? This faint glow of radiation left over from the Big Bang is one of the most important pieces of evidence we have for the origins of the universe. But recent studies have found anomalies in the cosmic microwave background, regions where the temperature appears slightly different than expected. Some researchers have speculated that filaments might be responsible for these anomalies, subtly distorting the cosmic microwave background in ways that we haven't accounted for. If this is true, then filaments could be leaving behind a cosmic fingerprint, an imprint on the oldest light in the universe that could tell us more about their role in shaping the cosmos. But what if filaments are doing something even more profound? What if they are acting as a kind of cosmic memory, storing information about the universe's past? We tend to think of the universe as a collection of galaxies, stars, and planets, but what if it is also a vast, interconnected information network? Some scientists believe that space-time itself might have a kind of memory, meaning that past events leave subtle imprints on the structure of the cosmos. If this is true, then filaments could be acting as the hard drive of the universe, preserving information about ancient cosmic events in ways we don't yet understand. Could filaments be the reason why certain structures in the universe seem to align in strange ways? Some studies have found that the rotation axes of distant galaxies appear to be aligned over vast cosmic distances, something that shouldn't be possible according to our current understanding of physics. Could filaments be guiding the motion of galaxies in ways we don't yet comprehend? If filaments are playing this hidden role, then it means that the universe is far more interconnected than we ever imagined. It suggests that galaxies are not just scattered randomly across space, but are part of a vast, cosmic web that influences their motion, their evolution, and perhaps even their fate. And if filaments are influencing the fate of galaxies, then what does this mean for our own Milky Way? Our galaxy is part of a much larger structure known as the Laniakea supercluster, a vast collection of galaxies connected by cosmic filaments. This means that the motion of our galaxy, its path through the universe, is not random. It is being guided by these unseen structures, shaped by forces we are only beginning to understand. Could it be that the ultimate fate of the Milky Way is already determined by the filaments that surround it? Could these cosmic structures be pulling us toward an inevitable future, one where our galaxy collides with others, merges into something new, or perhaps even falls into the gravitational grasp of a supermassive void? The deeper we look, the more it becomes clear that filaments are not just background features of the universe. They are fundamental to its structure, its evolution, and perhaps even its destiny. They guide the motion of galaxies, influence the behavior of dark matter, and may even be shaping the fundamental laws of physics themselves. And yet, we have only scratched the surface of what filaments truly are. With future telescopes and more advanced simulations, we may finally begin to unravel the full extent of their influence. We may discover that these cosmic highways are not just shaping the universe, they are shaping reality itself. But until then, filaments remain one of the greatest mysteries in astrophysics, a hidden force, stretching across the cosmos, guiding the universe in ways we are only beginning to understand. The deeper we dive into the mysteries of cosmic filaments, the more questions arise. If these vast, interconnected threads of dark matter and gas are truly responsible for the structure of the universe, then they must also play a role in some of the most fundamental cosmic processes, perhaps even influencing the nature of time itself. One of the strangest ideas emerging in modern physics is that time might not flow in a straightforward, linear way. Instead, some theories suggest that time is deeply connected to the fabric of space, influenced by the distribution of mass and energy throughout the cosmos. If this is true, could cosmic filaments, these massive, unseen structures, be subtly warping time as they stretch across billions of light years? It sounds like science fiction, but some researchers believe there could be a connection. If filaments are influencing the motion of galaxies, bending light, and acting as gravitational highways for matter, then it's possible they could also be creating tiny distortions in the passage of time. This could mean that time flows slightly differently depending on where you are in relation to these massive structures. And if filaments can warp time, could they also be affecting another fundamental aspect of the universe, gravity? Einstein's general theory of relativity tells us that gravity is not just a force but a curvature in space-time caused by massive objects. But what if filaments, stretching across billions of light years, are amplifying or distorting gravitational effects in ways we haven't yet understood? Some astronomers have already observed strange gravitational anomalies in deep space, regions where the motion of galaxies doesn't quite match our predictions. Could filaments be responsible? Could they be acting as invisible, large-scale gravitational lenses, subtly redirecting the paths of entire galaxies and changing the way we perceive the universe? If so, this could have massive implications for our understanding of dark matter. Right now, dark matter is one of the biggest unsolved mysteries in physics. We know it exists because we can see its gravitational influence, but we have no idea what it actually is. Some theories suggest dark matter is made up of exotic particles that don't interact with normal matter except through gravity. But what if filaments themselves are playing a role in the behavior of dark matter? Could it be that filaments are not just passive structures holding dark matter but are actively shaping its distribution? Could they be acting as reservoirs of dark matter, slowly feeding it into galaxies over time, influencing their growth and evolution in ways we've never realized? Some researchers have even proposed that filaments might be the key to unlocking the true nature of dark matter. If we could study them in more detail, mapping out their structure and influence with unprecedented precision, we might finally discover what dark matter really is, and in turn, uncover one of the greatest secrets of the universe. But dark matter isn't the only thing filaments might be influencing. Some scientists have begun to wonder if these structures could also play a role in the formation of life itself. It sounds like an extreme idea, but consider this: filaments guide the formation of galaxies, which in turn create stars and planets. If filaments control where galaxies form, then they might also determine where habitable planets can exist. This raises an astonishing possibility. Could the distribution of filaments throughout the universe be indirectly shaping the likelihood of life emerging in different regions of space? Could the cosmic web itself be a kind of grand architect, subtly increasing or decreasing the chances of life forming in different corners of the universe? If this is true, then our own existence might be deeply connected to the hidden structure of cosmic filaments. The reason we are here, on this planet, in this galaxy, could be tied to the way these invisible structures shaped the formation of the Milky Way billions of years ago. And if filaments influence life, then what about intelligence? Could they also play a role in determining where civilizations might arise? Some researchers have speculated that intelligent life might be more common in certain types of galaxies, ones with specific histories of star formation and chemical evolution. But if filaments control how galaxies grow, then they could also be indirectly shaping the emergence of intelligent civilizations. This idea leads to one of the biggest questions of all. If cosmic filaments guide the formation of galaxies, stars, and planets, could they also be influencing the development of consciousness itself? Could the grand structure of the universe be tied, in some mysterious way, to the evolution of minds capable of understanding it? The more we study filaments, the more we realize that they are not just background structures. They are fundamental to everything: the way galaxies move, the way matter clumps together, the way the universe itself evolves over billions of years. They are the hidden scaffolding of reality, guiding the fate of entire galaxies, shaping the fabric of space and time, and perhaps even influencing the conditions necessary for life itself. And yet, we have only begun to scratch the surface of what filaments truly are. The more we look, the more questions arise, leading us deeper into one of the greatest cosmic mysteries of all time. If cosmic filaments are as fundamental as they seem, then their influence might stretch even further than we currently understand. Some scientists are beginning to ask whether these vast structures could be responsible for even more unexpected phenomena, things that challenge our very perception of the universe. For instance, there's a growing discussion in astrophysics about whether filaments might be acting as conduits for an unknown form of cosmic energy. While we already know that filaments contain vast amounts of hot gas, dark matter, and galaxies, what if they also carry something else? An unknown force or energy field that subtly shapes the evolution of the universe. One radical idea is that filaments could be amplifying or guiding an exotic type of energy, something beyond the four fundamental forces of nature that we currently understand. Could filaments be transmitting unknown particles or waves across the cosmos, acting like massive, intergalactic highways for some yet-to-be-discovered energy? There are some strange hints that this could be the case. Some observations have revealed anomalies in the cosmic microwave background radiation, the afterglow of the Big Bang, that suggests there might be unseen structures influencing the way light travels across the universe. Could filaments be responsible? Could they be bending, distorting, or even subtly amplifying certain wavelengths of radiation in ways we don't yet comprehend? If true, this could mean that filaments are not just passive structures but active participants in the cosmic story. They could be amplifying the effects of dark energy, the mysterious force that is driving the accelerated expansion of the universe. Right now, we don't know what dark energy is. We only know that it makes up about 68% of the universe, and seems to be pushing galaxies apart at an ever-increasing rate. But what if filaments are somehow connected to dark energy? What if they act as massive, intergalactic channels that guide and shape the effects of this unknown force? Could they be acting like vast cosmic amplifiers, subtly influencing the way space itself expands? This would change everything we think we know about the universe. It would mean that filaments are not just structural components of space but active, dynamic forces shaping its very evolution. It would also mean that understanding filaments might be the key to unlocking the deepest mysteries of the cosmos, questions about the ultimate fate of the universe itself. If filaments influence dark energy, then they might also determine how the universe will end. Right now, there are multiple theories about the ultimate fate of the cosmos. One possibility is the Big Freeze, where the universe expands forever, cooling down and becoming increasingly empty. Another is the Big Rip, where dark energy eventually becomes so powerful that it tears apart galaxies, stars, and even atoms themselves. But if filaments are somehow connected to dark energy, then they could be playing a role in deciding which of these futures will come to pass. Could they be stabilizing the expansion of the universe, preventing it from ripping apart? Or could they be subtly accelerating it, pushing us toward an even stranger and more violent cosmic end? Some researchers have even proposed that filaments might be the missing link in understanding cosmic inflation, the brief period of rapid expansion that occurred just after the Big Bang. Inflation is one of the biggest mysteries in physics, and while we have some theories about what caused it, we still don't fully understand how it worked or what forces were involved. But what if filaments are relics of that ancient expansion? What if they formed as a result of inflation, acting as scars in the fabric of space-time that still shape the universe today? Could they hold clues about the very first moments of existence, helping us unlock the secrets of the Big Bang itself? This would mean that filaments are not just important for understanding the present-day universe. They might also hold the key to understanding its origins. They could be the fingerprints of the earliest moments of creation, the remnants of the forces that shaped reality itself. And if filaments connect to the birth of the universe, then they might also connect to something even more profound, the possibility of other universes. Some theories in modern physics suggest that our universe is not the only one. Instead, we might be part of a vast multiverse, with countless other universes existing beyond our own. If this is true, then filaments might be the cosmic threads that link different regions of the multiverse together. Could they be acting as bridges between universes, subtle connections between realities that we are only beginning to perceive? Could they be the cosmic stitching that holds the fabric of the multiverse together? This idea might sound like pure speculation, but some physicists believe it could be possible. There are certain anomalies in the cosmic microwave background radiation, regions of unusual temperature fluctuations, that some have suggested might be signs of interactions between our universe and another. Could filaments be playing a role in these interactions, acting as hidden passageways between different dimensions of existence? If so, then understanding filaments might not just help us understand our universe. It could help us unlock the secrets of the multiverse itself. It could mean that these vast structures, stretching across billions of light years, are not just shaping galaxies but shaping reality in ways we can barely begin to comprehend. The more we study filaments, the more they seem to be the key to everything. They determine where galaxies form, how matter moves, and possibly even how time and space evolve. They might be shaping dark matter, guiding dark energy, and influencing the fundamental forces of the cosmos. And yet, we are only at the beginning of our journey to understand them. New telescopes, more powerful simulations, and deeper studies of the universe will undoubtedly reveal even more about these hidden structures. But with every answer we uncover, new questions will arise, questions that could reshape our understanding of everything we thought we knew about the cosmos. Cosmic filaments are not just invisible threads stretching through space. They are the veins of the universe, the scaffolding of reality, the hidden forces that shape the fate of galaxies, stars, and perhaps even life itself. They are one of the greatest unsolved mysteries in astrophysics, and the deeper we explore them, the more we realize that they might hold the key to the deepest secrets of existence. The idea that cosmic filaments might be more than just structural components of the universe is gaining traction among astrophysicists. These colossal formations, spanning billions of light years, could be more than just highways of matter. They might be influencing the very fabric of reality itself. What if cosmic filaments are responsible for guiding the movement of dark matter in ways we haven't even begun to comprehend? Right now, we know that dark matter is the invisible substance that makes up around 85% of all the matter in the universe. It doesn't interact with light, making it impossible to see directly, but we can detect its presence through gravitational effects. Scientists suspect that filaments act as gravitational highways that pull dark matter into dense clusters, where galaxies eventually form. But could filaments be doing something even stranger? Perhaps acting as conduits that allow dark matter to interact in ways we don't yet understand? One of the biggest questions in astrophysics is whether dark matter is truly dark, or if it might possess its own interactions beyond gravity. Some theorists propose that dark matter could interact with itself through a force that we haven't yet detected. If this is true, cosmic filaments might be the perfect places to study these interactions, as they contain some of the highest concentrations of dark matter in the universe. Imagine if filaments were not just gathering dark matter but also causing it to behave in unexpected ways. Could they be regions where dark matter particles collide, exchange energy, or even annihilate each other? Some researchers have proposed that certain gamma-ray emissions detected in space might be signs of dark matter annihilation happening within filaments. If true, this could mean that filaments are not just passive structures. They could be playing an active role in shaping the mysterious, invisible substance that makes up most of the universe. Another question that arises is whether filaments could influence time itself. In Einstein's theory of general relativity, massive objects warp spacetime around them, creating gravitational wells. Given that filaments contain vast amounts of mass, both visible and dark, it's possible they could be stretching and bending spacetime in ways we haven't yet accounted for. Could time flow differently inside a filament? Could the gravitational influence of these structures be causing subtle distortions in the passage of time across the cosmos? Some astrophysicists speculate that if we were able to travel along a cosmic filament, we might experience small but measurable differences in time compared to other parts of the universe. If this were true, it would mean that filaments aren't just shaping matter, they might be subtly influencing the flow of time itself. And then there's an even more radical possibility. What if filaments are connected to wormholes? Wormholes are theoretical passages through spacetime that could, in theory, connect distant parts of the universe instantly. While no direct evidence of wormholes exists, some physicists have suggested that the immense gravitational fields of cosmic filaments could create conditions where spacetime folds in unexpected ways. Could filaments be naturally occurring bridges between distant galaxies, allowing for unknown cosmic phenomena to take place? Could they be shortcuts across the vast expanse of space, hidden highways that allow matter to travel across the universe in ways we haven't yet observed? The idea might sound like science fiction, but consider this: filaments already act as pathways for matter. If spacetime is more flexible than we currently believe, and if extreme gravitational forces can create warps in space, then it's not entirely impossible that filaments could be influencing the fundamental structure of the universe in ways we haven't imagined. Perhaps the biggest mystery of all is whether cosmic filaments are playing a role in the formation of life itself. It might seem counterintuitive. How could something as vast and lifeless as a cosmic filament have anything to do with life? But consider this: filaments guide the formation of galaxies, and galaxies contain the stars and planets that make life possible. If filaments didn't exist, the universe might be an entirely different place, one where galaxies were scattered randomly, where matter was distributed unevenly, and where conditions for life were far less stable. Some scientists even propose that filaments could have helped seed the early universe with the ingredients for life. The gas and dust that flow along filaments may have played a crucial role in distributing heavy elements, carbon, oxygen, nitrogen, across the cosmos. Without this process, the planets that eventually formed in galaxies might have been barren, lacking the necessary building blocks for life. This raises an even deeper question: if filaments helped shape the conditions for life in our universe, could they also be doing the same in others? If cosmic filaments exist in every universe, assuming the multiverse is real, then could they be a fundamental requirement for life to emerge? Could filaments be the cosmic blueprints that make the existence of intelligent civilizations possible? These questions push the boundaries of what we know about the universe. Every new discovery about cosmic filaments reveals just how crucial they are to the cosmic web that binds everything together. They are the backbone of the universe, the hidden scaffolding upon which galaxies, stars, and planets are built. They are the invisible hand that guides the evolution of everything we see in the night sky. And yet, we are only scratching the surface. The more we study these vast structures, the more they challenge our understanding of reality. Are they merely passive threads in the fabric of space, or are they something more? Do they hold the secrets to dark matter, dark energy, and the ultimate fate of the universe? Are they guiding forces that shape not just the cosmos, but the very nature of time, energy, and existence itself? The answers to these questions remain unknown, but one thing is certain: cosmic filaments are among the most mysterious and fascinating structures in the universe. As our technology advances and our telescopes grow more powerful, we will continue to unlock their secrets, revealing new insights into the hidden forces that shape the cosmos. Perhaps, one day, we will look back and realize that the key to understanding everything, the nature of space, time, and life itself, was hidden in these vast, silent filaments all along. The more we study cosmic filaments, the clearer it becomes that they are not just passive structures, but active players in the evolution of the universe. Their role in galaxy formation is already well documented, but what if their influence extends far beyond what we currently understand? One of the biggest open questions in astrophysics is how these filaments influence the distribution of matter on the largest scales. We know that galaxies form along these filaments, but could filaments also be influencing the movement of dark matter itself in ways we haven't accounted for? Some theories suggest that dark matter could be interacting within these filaments, possibly even influencing the flow of normal matter. If this is the case, it could explain some of the strange patterns we observe in large-scale cosmic structures, patterns that don't quite fit our current models of how matter should be distributed. A particularly intriguing possibility is that cosmic filaments might be acting as gravitational funnels, concentrating dark matter into certain regions while allowing other areas to remain relatively empty. If this is happening, it could mean that filaments are shaping not just where galaxies form, but also how they evolve over time. Could this process be responsible for some of the biggest cosmic voids, vast regions of space that seem almost completely empty? These voids, known as cosmic deserts, are some of the most puzzling structures in the universe. If filaments are actively pulling matter toward them, it could help explain why these voids are so incredibly barren. And then there's the question of how filaments might be influencing star formation on a local scale. We tend to think of galaxies as isolated systems, but the reality is that they are connected by these invisible threads. Gas and dust are constantly flowing along these filaments, feeding into galaxies and potentially playing a role in triggering star formation. Could it be that filaments act as intergalactic fuel lines, ensuring that galaxies continue to form new stars over billions of years? Some researchers have even suggested that certain types of galaxies might only exist because of the way filaments distribute matter. Dwarf galaxies, for example, tend to cluster around larger galaxies, and it's possible that filaments are responsible for funneling these smaller galaxies into place. If this is true, then filaments aren't just guiding the formation of galaxies, they're actively shaping their interactions and long-term evolution. But what if filaments are doing more than just moving matter? Could they also be influencing the movement of entire galaxy clusters? Observations have shown that some galaxy clusters appear to be moving in strange, unexpected ways, as if they are being pulled by an unseen force. One possible explanation is that these clusters are being affected by the gravitational pull of cosmic filaments. If filaments are capable of exerting such a strong influence, it could mean that they play a much bigger role in cosmic dynamics than we ever imagined. Another possibility that has gained attention in recent years is that cosmic filaments might be acting as conduits for unknown forces. Some physicists have proposed that there could be hidden interactions between dark matter and ordinary matter that only occur within these dense, high-gravity environments. If this is true, then filaments could be the key to unlocking some of the biggest mysteries in modern physics, including the true nature of dark matter itself. And what about dark energy? This mysterious force, which is thought to be responsible for the accelerating expansion of the universe, remains one of the greatest enigmas in science. Some researchers have speculated that dark energy might be interacting with cosmic filaments in subtle but significant ways. If filaments are influencing the distribution of dark matter, could they also be affecting the way dark energy behaves? Could these vast structures be playing a hidden role in the fate of the universe? The implications of these questions are profound. If filaments are actively shaping the evolution of the cosmos, then they might also be influencing the long-term future of the universe. Will they continue to guide the formation of galaxies indefinitely, or will they eventually fade away as the universe expands? Could they be responsible for the ultimate fate of matter itself? Some models suggest that as the universe continues to expand, filaments could become stretched and weakened over time. If this happens, the intricate web of cosmic structure could slowly unravel, leading to a future where galaxies drift apart, no longer bound by the gravitational pull of these hidden structures. But there's another, even more intriguing possibility. What if filaments are not just passive structures, but active components of a self-regulating system? Could the universe be maintaining its large-scale structure through processes we don't yet understand? Could filaments be part of a grand cosmic cycle, continuously forming, evolving, and even influencing the fundamental laws of physics themselves? These are questions that push the limits of what we currently know, but they are also the kinds of questions that drive scientific progress. If there's one thing we can say for certain, it's that cosmic filaments are among the most fascinating and mysterious structures in the universe. They are the invisible skeleton upon which everything is built, the hidden forces shaping galaxies, stars, and perhaps even the nature of reality itself. The more we learn about them, the more they challenge our understanding of the cosmos. Are they merely the threads that hold the universe together, or are they something more? Could they be the key to unlocking the deepest secrets of space, time, and existence? As our technology improves and our observations become more precise, we will continue to uncover new insights into these vast structures. And perhaps, one day, we will finally unravel the true nature of cosmic filaments, revealing a universe even stranger and more complex than we ever imagined. The more scientists investigate cosmic filaments, the more it becomes clear that they are not just passive highways for matter but dynamic, evolving structures that might be playing a crucial role in shaping the universe itself. One of the most puzzling aspects of these filaments is their sheer scale. Some of the largest filaments discovered stretch for hundreds of millions of light years, forming colossal bridges of matter between galaxy clusters. These structures are so vast that, from our perspective, they appear to be almost static. However, over cosmic timescales, they are anything but. Recent simulations suggest that cosmic filaments are slowly evolving, stretching and shifting as the universe expands. But what's truly fascinating is that they appear to be influencing galaxy formation in ways we still don't fully understand. Some galaxies seem to form preferentially along filaments, while others appear to be repelled by them. Why? The answer likely has to do with the complex gravitational interactions at play. When matter collapses into a filament, it doesn't do so uniformly. Instead, some regions become denser than others, creating pockets where galaxies can form more easily. But at the same time, the gravitational forces exerted by these filaments can also act to push matter away in certain regions, potentially explaining why we see vast cosmic voids in some areas of the universe. These voids, sometimes spanning hundreds of millions of light years, remain one of the greatest unsolved mysteries in cosmology. Could filaments be actively shaping the distribution of matter in ways we don't yet comprehend? Another major question is how filaments themselves formed in the first place. The leading theory suggests that after the Big Bang, tiny fluctuations in the density of matter led to the formation of large-scale structures over billions of years. But there's something strange about this process. According to standard models of cosmology, filaments should be much more uniform in their structure. Instead, observations show that some filaments are significantly denser than others, and some appear to contain much more dark matter than expected. This raises an intriguing possibility. Could cosmic filaments be acting as reservoirs for hidden forms of matter? Some researchers have proposed that filaments might be sites where unknown particles, possibly even components of dark matter, accumulate over time. If this is the case, then studying filaments in more detail could provide crucial insights into one of the biggest mysteries in physics: the nature of dark matter itself. Dark matter, despite making up roughly 85% of the total matter in the universe, has never been directly observed. We only know of its existence because of its gravitational effects on galaxies and large-scale structures. But what if filaments are the key to unlocking its secrets? Some studies suggest that filaments might contain more dark matter than previously thought, potentially acting as gravitational wells that shape the evolution of the cosmos. And then there's the even bigger question: what role do filaments play in the evolution of supermassive black holes? Every large galaxy we've observed so far contains a supermassive black hole at its center. These black holes, millions or even billions of times the mass of our Sun, seem to have formed incredibly early in the history of the universe. But how did they grow so fast? Some scientists now believe that cosmic filaments might be part of the answer. If filaments act as cosmic highways for matter, then they could also be funneling material directly into the centers of galaxies, feeding their central black holes and allowing them to grow much more quickly than we previously thought possible. This could explain why we see some black holes that are much larger than they should be, based on our current models of galaxy evolution. But what about the possibility that filaments themselves might be influencing the very fabric of space-time? Some radical theories suggest that cosmic filaments might not just be passive structures but could be actively shaping the way gravity works on large scales. If true, this could have profound implications for our understanding of physics, potentially challenging our current models of general relativity. One idea is that filaments might be acting as conduits for a yet undiscovered force, one that only becomes significant on cosmic scales. Could this be the missing link that explains the mysterious force of dark energy, which is driving the accelerated expansion of the universe? If filaments are somehow interacting with dark energy, it could mean that they are not just shaping galaxies, but playing a direct role in the ultimate fate of the universe itself. Another aspect of cosmic filaments that remains mysterious is their magnetic fields. Recent observations have shown that filaments are not just made of matter, they also contain magnetic fields that stretch across vast distances. These fields are incredibly weak compared to the magnetic fields found in galaxies, but their presence is puzzling. How did they form? And could they be playing a hidden role in galaxy evolution? Some scientists speculate that these magnetic fields could be influencing the motion of charged particles within filaments, potentially affecting the way matter flows through them. If true, this could mean that filaments are not just passive structures but are actively shaping the movement of gas and dust, influencing where and how galaxies form. But there's yet another mystery. Are filaments truly stable, or are they evolving in ways we don't yet understand? Some simulations suggest that filaments might be slowly breaking apart over time, as the universe continues to expand. If this is true, then the cosmic web we see today might look very different in the far future. Could we be living in a unique era of cosmic history, where filaments are still actively shaping the universe but will one day disappear? Some researchers even suggest that the study of cosmic filaments could lead to breakthroughs in fundamental physics. If we can understand how filaments formed and how they influence matter, it might help us solve some of the biggest unanswered questions about the early universe. Could filaments be relics of a time before the Big Bang? Some radical theories propose that the universe may have undergone cycles of expansion and contraction, with filaments acting as remnants of previous cosmic epochs. And what if filaments are more than just structures? What if they are part of a deeper cosmic order that we have yet to uncover? Some physicists have speculated that the intricate patterns formed by filaments might be revealing hidden symmetries in the laws of physics. If true, this could lead to a fundamental shift in our understanding of reality itself. For now, cosmic filaments remain one of the greatest mysteries of the universe. They are the invisible scaffolding upon which galaxies are built, the hidden highways along which matter flows, and possibly even the key to unlocking the deepest secrets of dark matter, dark energy, and the evolution of the cosmos. But the more we learn about them, the more questions arise. What forces are truly at work within these vast structures? Are they passive or active participants in the cosmic story? Could they be revealing hidden laws of nature that we have yet to understand? One thing is certain, the study of cosmic filaments is only just beginning. With new telescopes and more advanced simulations, we are slowly peeling back the layers of this grand cosmic web. And perhaps, in the near future, we will finally uncover the true role that filaments play in shaping the universe itself. One of the most baffling questions surrounding cosmic filaments is their connection to dark energy. Dark energy is the mysterious force that appears to be accelerating the expansion of the universe. Scientists have long struggled to understand its true nature, but some theories now suggest that cosmic filaments could be playing a hidden role in this process. If filaments are acting as gravitational channels that funnel matter across the universe, then they might also be influencing the overall expansion of space. Some researchers have proposed that dark energy might not be uniformly distributed across the cosmos. Instead, it could be interacting with filaments in ways that cause certain regions of the universe to expand at different rates. This would mean that filaments aren't just passive structures but active players in the cosmic expansion process. Recent simulations have shown that filaments might actually be stretching over time due to the influence of dark energy. If this is true, then filaments could be acting as cosmic elastic bands, slowly pulling apart as the universe expands. But here's where things get even stranger. Some observations suggest that filaments are also pulling galaxies toward them, even as they stretch outward. This creates a paradox. How can filaments be both expanding and drawing matter inward at the same time? One possible explanation is that filaments are acting as cosmic conveyor belts, continuously funneling matter toward denser regions while also stretching due to the expansion of space. This could mean that filaments are influencing galaxy formation in ways we've never considered before. Instead of galaxies simply forming wherever there is enough matter, they might actually be guided into place by the gravitational forces of filaments. This idea is supported by observations showing that galaxies don't just form randomly. They align along filaments in strikingly organized patterns. Some astronomers believe that this alignment is not just a coincidence but a direct result of the way filaments channel the flow of matter. If true, then this could fundamentally change our understanding of galaxy formation. Another strange discovery is that the spin of galaxies seems to be influenced by cosmic filaments. Observations have shown that galaxies located near filaments tend to rotate in a particular direction, almost as if the filaments are imparting a cosmic twist to them. This phenomenon, known as galactic spin alignment, is one of the most puzzling aspects of cosmic filaments. How is this possible? One theory suggests that filaments are not just structures made of matter but are also spinning themselves. If filaments possess a form of large-scale rotational motion, then they could be transferring angular momentum to galaxies as they form. This would mean that the cosmic web is not just a static structure but a dynamic, rotating system that actively influences the motion of galaxies. If filaments are spinning, then this could have profound implications for our understanding of the early universe. Could this rotation be a leftover imprint from the very first moments after the Big Bang? Some cosmologists believe that the initial conditions of the universe may have set certain regions into motion, creating a large-scale cosmic spin that still affects galaxies today. But here's where things get even more mind-blowing. Some researchers have suggested that filaments could be acting as cosmic bridges between parallel universes. This idea, which comes from certain interpretations of string theory and extradimensional physics, proposes that filaments might not just be structures within our own universe but connections to hidden layers of reality. If this is true, then filaments could be much more than just physical structures made of matter and dark matter. They could be the key to understanding the very nature of space-time itself. Some radical theories propose that filaments might be acting as conduits for exotic particles that only exist in higher dimensions. If we could study these particles, it might provide direct evidence for the existence of extra dimensions beyond our own. This could also help explain some of the strange gravitational effects that filaments exhibit. Some filaments appear to have more gravitational influence than they should, based on the amount of matter they contain. If these filaments are interacting with forces from another dimension, then it might explain why their gravitational pull seems to defy our current understanding of physics. And then there's the question of how filaments might evolve over time. If filaments are slowly stretching due to dark energy, then what happens to them in the distant future? Will they continue to stretch until they eventually break apart? Or could they reach a critical point where they collapse, triggering massive cosmic events? Some theories suggest that filaments might eventually become so stretched that they fragment into smaller structures. If this happens, it could mean that the large-scale structure of the universe is not permanent but is constantly changing over billions of years. This could also mean that the cosmic web we see today is just a temporary phase in the evolution of the universe. But what if filaments never truly disappear? What if they are fundamental structures that persist even as the universe continues to evolve? Some physicists have proposed that filaments might be linked to fundamental cosmic forces that govern the entire structure of space-time. If true, then studying filaments could provide insights into the deepest laws of physics. Another mind-bending possibility is that filaments might be related to cosmic strings, hypothetical one-dimensional objects predicted by certain theories of quantum gravity. Cosmic strings, if they exist, could be remnants of the early universe, stretching across vast distances and influencing the formation of galaxies. If filaments and cosmic strings are connected, then it could mean that the cosmic web is not just a structure of ordinary matter but a relic of the fundamental forces that shape the universe itself. And what if filaments are playing a role in the ultimate fate of the universe? Some cosmologists believe that the expansion of the universe will continue indefinitely, leading to a heat death, where all matter is evenly spread out and nothing new can form. But if filaments are actively funneling matter into galaxies, then this process might continue for much longer than previously thought. Could filaments be the key to extending the lifespan of the universe? Or could filaments themselves be part of a much larger cosmic cycle? Some theories suggest that the universe undergoes cycles of expansion and contraction, with filaments acting as the structural framework that persists through each cycle. If this is true, then filaments might not just be temporary features of our universe but eternal structures that exist beyond time itself. For now, the mysteries of cosmic filaments remain unsolved. But as our technology improves and our understanding of the universe deepens, we may one day unlock the true nature of these colossal structures. Are they simply vast networks of matter, or could they be something far more profound, cosmic highways that connect the deepest mysteries of space-time? One thing is certain: the more we study filaments, the more questions we uncover. They are the hidden backbone of the universe, shaping galaxies, influencing cosmic expansion, and possibly even revealing secrets about the fundamental nature of reality. And as we continue to explore the cosmos, we may find that filaments hold the key to understanding not just our universe, but the very fabric of existence itself. We have to explore one of the strangest ideas yet: the possibility that filaments could be influencing the flow of time itself. This might sound like pure science fiction, but some theoretical physicists believe that the way matter moves through filaments could have subtle effects on time dilation, similar to how gravity affects time near massive objects like black holes. If filaments are truly stretching across billions of light years and channeling matter through their gravitational pull, then space-time itself could be slightly warped within these structures. This warping might not be as extreme as what happens near a black hole, but it could still be significant enough to create tiny variations in the passage of time. Some researchers speculate that galaxies forming along filaments might experience slightly different rates of time compared to those in more isolated regions of the universe. This concept ties into another mystery: why galaxies seem to have formed and evolved at different rates across cosmic history. Some galaxies appear older than they should be based on their distance from us, while others seem strangely young. Could filaments be playing a hidden role in this? If filaments subtly influence time dilation, then the galaxies within them might be evolving at slightly different speeds compared to those in voids. The connection between filaments and time doesn't stop there. Some researchers have suggested that filaments could act as time highways for particles, allowing certain high-energy particles to move through space in unusual ways. This could help explain some of the strange cosmic rays detected by telescopes, which appear to be coming from incredibly distant sources at unexpected energy levels. If filaments provide preferred pathways for these particles, then they might be influencing how energy moves through the cosmos in ways we don't yet understand. Beyond time, filaments might also hold the key to one of the greatest cosmic mysteries: the nature of dark matter. Observations suggest that filaments are not just made of ordinary matter but contain significant amounts of dark matter as well. In fact, some studies indicate that filaments could be one of the best places to detect and study dark matter, since it is thought to be more densely concentrated in these structures than in the vast empty voids of space. But what if dark matter isn't just passively sitting within filaments? What if filaments are actually shaping the behavior of dark matter in ways we haven't yet realized? Some theories propose that filaments might be influencing the distribution and movement of dark matter, possibly even affecting how it interacts with gravity on cosmic scales. If true, this could mean that filaments are not just shaped by dark matter but are actively influencing its structure in return. One of the biggest challenges in studying dark matter is that it doesn't interact with light, making it nearly impossible to observe directly. However, filaments might provide an indirect way to study it. Some astronomers are looking at how filaments bend light from distant galaxies, a phenomenon known as gravitational lensing, to map out where dark matter might be hiding. If filaments are acting as cosmic magnifying glasses, then they could help us uncover the invisible scaffolding of the universe. Another fascinating idea is that filaments could be sites of unknown physical processes that we haven't yet discovered. Could filaments be producing exotic particles that only exist under extreme cosmic conditions? Some physicists speculate that filaments might be locations where strange quantum effects occur on macroscopic scales. If true, this could mean that filaments are not just passive structures but active environments where new physics is taking place. Some radical theories even suggest that filaments might be connected to concepts from quantum mechanics, such as entanglement. Could filaments be acting as giant quantum networks, linking different parts of the universe in ways we can't yet comprehend? If filaments have properties similar to quantum entanglement, then they could be playing a role in the fundamental structure of reality itself. But perhaps the most mind-boggling possibility is that filaments could be remnants of a previous universe. Some cosmologists believe that our universe is not the first, but is part of an endless cycle of cosmic birth and rebirth. If true, then filaments might be leftover structures from a past universe, carrying hidden imprints of an earlier cosmic era. This could help explain why filaments seem to have such a strong influence on galaxy formation and cosmic structure. If filaments are ancient relics from a previous cosmic cycle, then they might contain information about the fundamental forces that shape not just our universe, but all universes before it. Could filaments be the key to unlocking the secrets of the multiverse? And what if filaments are not just remnants but active conduits between different cosmic cycles? Some speculative theories suggest that filaments might be acting as bridges between different eras of cosmic evolution, allowing matter and energy to flow between different phases of the universe. If this is true, then filaments might be more than just structures within our universe. They could be cosmic threads linking the past, present, and future in ways we can't yet grasp. These ideas may sound extreme, but the more we study cosmic filaments, the more they challenge our understanding of the universe. They are not just vast networks of matter, they are shaping the very fabric of space-time itself. As new telescopes and simulations continue to uncover their secrets, we may soon realize that filaments are far more than just the backbone of the cosmos. They could be the key to answering some of the biggest questions in physics, astronomy, and the nature of existence itself. Let's consider their potential role in shaping the large-scale fate of the universe itself. If filaments are the highways along which galaxies form and move, then understanding their behavior could give us clues about the ultimate destiny of the cosmos. Will the universe expand forever? Will it slow down and collapse? Or is there a far stranger fate awaiting us, one tied to the hidden properties of filaments? One of the most perplexing mysteries in cosmology is the accelerating expansion of the universe. According to what we know, gravity should be slowing the expansion down, yet observations show that distant galaxies are moving away from us faster and faster over time. Scientists attribute this to a mysterious force called dark energy, which seems to be pushing the universe apart. But where does dark energy come from? Some researchers have begun to speculate that filaments might be playing a role in how dark energy behaves. The structure of the cosmic web, with its vast voids and dense filaments, could be influencing how energy is distributed across the universe. If filaments act as gravitational channels, then they could be subtly affecting the expansion of space in ways we don't yet understand. There's even a possibility that filaments themselves might be sources of dark energy, or at least interacting with it in ways we haven't detected yet. If filaments contain massive amounts of dark matter, and dark matter interacts with dark energy, then filaments could be the missing link in understanding why the universe's expansion is accelerating. And then there's another, even stranger possibility. What if filaments are influencing the fundamental laws of physics over cosmic timescales? Some radical theories suggest that the fundamental constants of nature, such as the strength of gravity or the speed of light, might not actually be constant. Instead, they could evolve over billions of years, changing the way the universe behaves. If this is true, then filaments, as the largest structures in the universe, might be playing a hidden role in shaping these changes. One way this could happen is through the movement of matter and energy within filaments. If filaments act as channels for the flow of cosmic material, then they could be redistributing energy in ways that gradually shift the balance of forces in the universe. This could mean that different regions of the cosmos experience slightly different physical laws depending on how filaments are structured. Another possibility is that filaments are not just shaping galaxies, but entire cosmic epochs. What if filaments serve as dividing lines between different eras of cosmic evolution? If filaments contain large amounts of dark matter and possibly exotic unknown particles, then they might be acting as transition zones between different phases of the universe's history. Some scientists have even speculated that filaments could be linked to the mysterious phenomenon of cosmic voids, the vast empty spaces between galaxy clusters. While filaments are the dense highways of the universe, voids are like the vast deserts in between. But what if these voids aren't just empty? What if they are places where the laws of physics operate differently? Some researchers suggest that the interaction between filaments and voids could be creating unknown forms of energy, or even entire new regions of the universe with different physical properties. If this is true, then filaments might not just be shaping the cosmos. We might be living in a universe where filaments are actively creating and destroying different regions of space-time itself. And then there's the question of whether filaments could be influencing the future direction of cosmic evolution. If filaments continue to pull galaxies toward them, and dark energy continues to push space apart, then what happens in the distant future? Will galaxies remain bound to filaments, or will they eventually be flung apart, leaving behind a universe where even filaments are stretched into nothingness? Some theories suggest that filaments might eventually unravel, causing galaxies to drift away from each other into a cold, empty void. Others propose that filaments could collapse under their own gravity, triggering new cycles of galaxy formation and possibly even new universes. But what if filaments have an even more profound role? What if they are not just structuring the universe, but actively shaping the way reality itself works? Some physicists propose that the structure of space-time might not be smooth and continuous but instead have a hidden, deeper structure, one that filaments could be revealing. Could filaments be physical manifestations of a deeper, hidden order in the universe? If filaments are shaping the way matter and energy behave on cosmic scales, then they might be the visible traces of something even larger and more mysterious, a deeper framework that underlies all of reality. As we continue to study cosmic filaments, we might not just be learning about galaxy formation. We might be uncovering secrets about the very nature of space, time, and the ultimate fate of the cosmos. Filaments could be the key to understanding why the universe looks the way it does, how it evolved, and where it's headed. And perhaps, just perhaps, they hold the answers to questions we haven't even thought to ask yet. The deeper we look into the universe, the more we realize that cosmic filaments might be more than just massive structures of matter. They could be fundamental components of reality itself. If filaments are not just passive conduits for galaxies but active shapers of cosmic evolution, then their influence may extend far beyond what we currently understand. One of the most intriguing possibilities is that filaments could be playing a role in the distribution of fundamental forces. Gravity, electromagnetism, the strong nuclear force, and the weak nuclear force are the four known fundamental forces of nature. But what if these forces are not as constant as we assume? If filaments are massive structures with an immense gravitational pull, then they might be distorting the behavior of these forces on a cosmic scale. There are already hints that the laws of physics might vary across different parts of the universe. Some studies suggest that the fine structure constant, a fundamental constant related to the strength of electromagnetic interactions, may be slightly different in different regions of space. If this is true, then filaments could be influencing these variations. Their immense gravitational fields, combined with the presence of dark matter and possibly unknown exotic particles, could be subtly altering the way fundamental forces behave in different cosmic neighborhoods. This could have profound implications for our understanding of the universe. If filaments are affecting the fundamental forces, then they might also be shaping the very fabric of spacetime itself. General relativity tells us that massive objects warp spacetime, but what if filaments are warping spacetime on a level we don't yet understand? Some scientists propose that filaments could be linked to the mysterious phenomenon of cosmic anisotropy, the idea that the universe might not be the same in all directions. While we often assume the cosmos is uniform on large scales, there are strange anomalies in the cosmic microwave background radiation, the leftover light from the Big Bang, that suggest the universe may have a preferred direction. Could filaments be responsible for this? If filaments are influencing the shape and structure of spacetime, then they might also be playing a role in the flow of time itself. Time is often thought of as a constant, but what if it isn't? If spacetime is being stretched and twisted by massive filaments, then different regions of the universe might experience time at different rates. This could have staggering consequences for our understanding of cosmology. And what about the possibility that filaments are connected to the mysterious concept of quantum gravity? One of the biggest unsolved problems in physics is how to reconcile general relativity, which describes gravity, with quantum mechanics, which describes the behavior of particles on the smallest scales. Filaments, as the largest known structures in the universe, might be the missing link in understanding how gravity behaves at both the cosmic and quantum levels. Some researchers have even speculated that filaments could be linked to the idea of higher dimensions. If extra dimensions exist beyond the three we experience, then filaments could be revealing hidden aspects of the universe we can't normally see. Could filaments be three-dimensional projections of even larger, multidimensional structures? If so, then studying filaments might not just tell us about the universe we see, it might give us a glimpse into a much deeper reality. Another tantalizing possibility is that filaments could be acting as cosmic conduits for unknown forms of energy, or even information. Some theories suggest that space itself might be a kind of computational structure, processing information on a fundamental level. If this is true, then filaments, as the largest structures in the universe, could be playing a role in the way information is transmitted across cosmic scales. Could filaments be the universe's way of organizing and processing information on a level we don't yet comprehend? There's also the question of whether filaments might be influencing the behavior of dark matter and dark energy in ways we haven't yet detected. Dark matter is still a mystery. It doesn't interact with light, but we know it exists because of its gravitational effects. If filaments are dense regions where dark matter is concentrated, then they could be key to unlocking its secrets. And what about dark energy, the force driving the universe's accelerating expansion? If filaments are interacting with dark energy, then they might not just be shaping galaxies, they could be shaping the ultimate fate of the cosmos. If dark energy continues to push galaxies apart, will filaments eventually unravel? Or could they act as anchors, holding certain regions of the universe together even as space expands? Some radical theories suggest that filaments could even be gateways to other universes. If the multiverse exists, if there are other universes beyond our own, then filaments could be the points where different universes connect. These structures could be cosmic bridges, linking different realities in ways we can't yet perceive. If this is true, then studying filaments might not just teach us about our own universe. It might give us clues about the existence of parallel worlds, alternate dimensions, or even the fundamental nature of reality itself. As our telescopes and simulations improve, we are beginning to see filaments in greater detail than ever before. But with each discovery, new questions arise. Are filaments truly the skeleton of the universe, or are they something far more profound? Are they simply massive structures of gas and dark matter, or are they revealing deeper truths about space, time, and the nature of existence? One thing is certain, filaments are far more than just cosmic highways for galaxies. They might be the key to understanding some of the greatest mysteries in physics, cosmology, and even the nature of reality itself. And as we continue to explore the universe, filaments may be the path that leads us to answers we never even thought to ask. The more we study cosmic filaments, the more it becomes clear that they may hold the answers to some of the most fundamental questions in cosmology. One of the most perplexing mysteries is the relationship between filaments and the large-scale structure of the universe. The cosmic web is composed of filaments, voids, and clusters, but what determines their arrangement? Is it purely the result of gravity and dark matter interactions, or is there a deeper underlying principle that dictates the distribution of these massive structures? One possibility is that the formation of filaments follows patterns dictated by unknown physical laws that go beyond our current understanding of cosmology. Some researchers have proposed that filaments might be forming along invisible lines of force that stretch across the universe, similar to the way magnetic field lines guide the movement of charged particles. If true, this could mean that the structure of the universe is not just a product of gravity, but also of hidden, large-scale forces that we have yet to identify. This idea becomes even more intriguing when we consider the concept of cosmic inflation. According to the inflationary model of the universe, in the moments after the Big Bang, space expanded faster than the speed of light. This rapid expansion could have imprinted certain structural patterns onto the universe, setting the stage for the formation of filaments billions of years later. If this is true, then studying filaments might allow us to glimpse the physical laws that govern the earliest moments of existence. There's also the question of whether filaments themselves might be influencing the movement of galaxies in ways we don't yet fully understand. We already know that galaxies are drawn toward filaments due to their immense gravitational pull, but recent simulations suggest that filaments might also be subtly altering the rotation of galaxies. In other words, filaments might not just be highways for galaxies, they might be shaping their very structure and behavior. This could help explain a long-standing mystery in astrophysics: the discrepancy between the observed and predicted rotation curves of galaxies. According to Newtonian physics, galaxies should spin in a way that reflects the distribution of visible matter within them. However, observations show that galaxies rotate at speeds that suggest there is far more mass than we can see. This is one of the key pieces of evidence for dark matter. But what if filaments are also playing a role? If filaments are interacting with galaxies in unexpected ways, they could be contributing to the rotational discrepancies we observe. Some scientists have even proposed that filaments might be acting as conduits for a previously unknown form of matter, one that could be influencing galaxies without emitting light. If this is the case, then our current models of galactic evolution might need to be revised. But filaments might be doing more than just shaping the movement of galaxies. They could also be influencing the birth of stars on a cosmic scale. Star formation is a complex process that depends on many factors, including the density of gas clouds, the presence of heavy elements, and the influence of nearby supernova explosions. However, recent observations suggest that filaments might be providing the perfect conditions for star formation by funneling gas into certain regions of space. In some cases, filaments seem to be acting like cosmic rivers, channeling vast amounts of gas toward galaxy clusters. This influx of material could trigger bursts of star formation, leading to the rapid growth of galaxies. If filaments are actively fueling star formation, then they are not just passive structures. They are playing a crucial role in shaping the evolution of the universe. And what about the possibility that filaments might be influencing the very nature of space-time itself? If filaments contain vast amounts of dark matter, then their gravitational fields could be stretching and warping spacetime in unexpected ways. This could have profound implications for our understanding of cosmic expansion and the nature of the universe's ultimate fate. Some theories suggest that filaments might even be connected to the mysterious force known as dark energy. Dark energy is thought to be responsible for the accelerating expansion of the universe, but we still don't know what it is. If filaments are interacting with dark energy in some way, then they could be playing a role in determining the long-term evolution of the cosmos. One radical idea is that filaments might be acting as cosmic scaffolding, holding galaxies together against the expansive pull of dark energy. If true, then the fate of the universe could depend on the balance between these two opposing forces. Will dark energy eventually overcome the gravitational pull of filaments, tearing apart the cosmic web and leaving only isolated galaxies drifting in an ever-expanding void? Or could filaments serve as anchors, preserving the structure of the universe even as space itself continues to expand? There is also the possibility that filaments could be acting as cosmic information highways. Some researchers have speculated that space itself might be a kind of computational system, processing information at a fundamental level. If this is true, then filaments could be the universe's way of transmitting information across vast distances, linking different regions of space in ways we don't yet understand. Could filaments be carrying signals from one part of the universe to another? If so, then studying these structures might not just tell us about the physical nature of the cosmos. It might reveal new insights into the fundamental nature of reality itself. As our understanding of filaments continues to grow, one thing becomes clear: these vast cosmic structures are far more than just threads of gas and dark matter. They might be the key to unlocking some of the greatest mysteries in physics, from the nature of dark matter and dark energy to the fundamental forces that shape the universe. But perhaps the most mind-bending possibility of all is that filaments might be revealing the true structure of reality itself. If the universe is fundamentally connected through these vast networks, then everything we see, from the tiniest particles to the largest galaxies, might be part of a single, interconnected system. If this is true, then filaments might not just be the highways of the cosmos. They might be the very framework upon which the universe is built. And as we continue to explore these vast, hidden structures, we may be on the verge of uncovering secrets that will change our understanding of the cosmos forever. The deeper we dive into the mysteries of cosmic filaments, the more they challenge our understanding of the universe. These immense structures are not just passive strands of matter, they seem to influence everything around them, from the way galaxies form and move to potentially even shaping the very fabric of space-time itself. But what if they hold secrets that go beyond our current physics? One of the biggest questions about filaments is their relationship with dark matter. We already know that dark matter plays a key role in the formation of the cosmic web, but what if filaments themselves are made primarily of dark matter? If this is the case, then they might not just be guiding galaxies. They could be acting as hidden reservoirs of unseen mass, influencing the evolution of the universe in ways we haven't yet considered. Some theories suggest that filaments could be channels for exotic particles, potentially even a form of matter that interacts with dark matter in ways that are completely invisible to us. If such interactions exist, then filaments might be holding together the structure of the universe in a way that is fundamentally different from how normal matter behaves. In other words, we might be looking at the backbone of the universe without fully understanding what it's made of. This raises another fascinating possibility. Could filaments be responsible for unexplained gravitational anomalies? We already know that the gravitational effects of dark matter can't be directly observed. We infer its existence based on how galaxies move. But what if filaments themselves are warping space-time more than we realize? If so, then they might be influencing gravitational waves, the ripples in space-time caused by massive cosmic events. Gravitational waves were first detected in 2015, and since then, scientists have been studying them to learn more about the universe. But if filaments are affecting these waves, it could mean that our understanding of gravity is incomplete. Some researchers have even proposed that filaments might be acting like cosmic lenses, bending gravitational waves in ways we haven't yet accounted for. This could mean that our observations of distant black hole mergers and neutron star collisions are being subtly distorted by the vast networks of filaments that stretch across the cosmos. And what about the possibility that filaments themselves could be acting as conduits for energy transfer on a cosmic scale? We know that filaments contain massive amounts of hot gas, and that they help funnel material into galaxy clusters. But what if they are also transporting energy in ways we don't yet understand? Some theories suggest that filaments could be acting as cosmic pipelines, transferring heat and radiation between galaxies in a way that helps regulate the temperature of the universe. If this is true, then filaments might not just be shaping the distribution of galaxies. They could be playing a direct role in determining the physical properties of space itself. This could help explain some of the strange temperature variations observed in the cosmic microwave background, the faint glow left over from the Big Bang. If filaments are influencing how energy moves through the universe, then they might be leaving subtle imprints on the very radiation that fills all of space. There's also the question of how filaments interact with supermassive black holes. Every large galaxy is thought to have a supermassive black hole at its center, and these black holes are known to have an immense impact on their surroundings. But what if filaments are somehow connected to the growth of these cosmic giants? Some scientists believe that filaments might be feeding black holes, providing a steady stream of gas and matter that fuels their growth. If this is the case, then filaments could be playing a direct role in the evolution of galaxies by determining how much material is available for black holes to consume. This could help explain why some galaxies have extremely active black holes while others remain relatively quiet. But what if filaments are doing something even more unexpected? Some recent studies have suggested that black holes might be producing jets of energy that travel along filaments, extending for millions of light years. If this is true, then filaments could be acting as channels for some of the most energetic processes in the universe, guiding the movement of plasma and radiation across vast cosmic distances. This leads to an even more mind-bending possibility. Could filaments be part of a hidden structure that connects black holes across the universe? Some theoretical physicists have proposed that space-time itself might be woven together in a way that allows information to travel between distant regions of the cosmos. If filaments are playing a role in this, then they might not just be shaping the universe. They could be acting as a kind of cosmic network, linking different regions of space in ways we don't yet understand. This idea ties into a controversial hypothesis known as the holographic principle, which suggests that the universe might be fundamentally connected in ways that defy our traditional understanding of physics. If filaments are involved in this process, then they could be providing clues to a deeper reality, one in which space, time, and matter are interconnected in ways we have yet to fully grasp. And what if filaments are not just physical structures, but part of a larger cosmic cycle that repeats over and over again? Some cosmologists have proposed that the universe might go through cycles of expansion and contraction, with filaments acting as the scaffolding that holds everything together between cycles. If this is true, then studying filaments might give us insight into the ultimate fate of the universe, whether it will continue expanding forever, collapse into a singularity, or transition into a new phase of existence. These questions push the boundaries of what we know about the cosmos, and they challenge us to think in new ways about the hidden structures that shape reality. Cosmic filaments might be the key to answering some of the biggest mysteries in physics, from the nature of dark matter and dark energy to the very structure of space-time itself. And as we continue to explore these vast, unseen highways of the universe, we may find that they are far more than just the scaffolding of galaxies. They might be the fundamental threads that weave together the fabric of reality itself. Cosmic filaments may be the most fundamental structures in the universe, but what if they are more than just highways for matter? What if they hold the key to understanding some of the most perplexing cosmic phenomena, from the origin of the first galaxies to the fate of the universe itself? These massive strands of gas and dark matter are not just passive structures. They could be actively shaping the evolution of the cosmos in ways we are only beginning to understand. One of the biggest questions surrounding cosmic filaments is how they influence the formation of the earliest galaxies. We know that shortly after the Big Bang, the universe was a chaotic sea of hot plasma. Over time, gravity caused matter to clump together, forming the first stars and galaxies. But this process wasn't random. Something guided the distribution of matter, helping shape the cosmic web. Filaments appear to be the answer. It turns out that galaxies don't just form anywhere in space. They are drawn toward the intersections of filaments, where the density of matter is highest. This suggests that filaments act as cosmic assembly lines, channeling gas and dust into growing galaxies. Without filaments, galaxy formation might have been a much slower, more inefficient process. But this raises another question: are filaments responsible for the uniformity of the universe? When we look at the cosmic microwave background radiation, the faint afterglow of the Big Bang, we see that the universe is remarkably uniform on large scales. But small variations in density eventually led to the formation of galaxies, stars, and planets. If filaments played a role in this process, they might be the missing link between the smooth early universe and the structured cosmos we see today. This idea leads to even deeper mysteries. If filaments help form galaxies, do they also dictate how those galaxies evolve? Some scientists believe that the motion of galaxies along filaments could influence their shapes, sizes, and even their ability to form new stars. Observations show that spiral galaxies tend to be aligned with filaments, while elliptical galaxies often sit at the intersections where filaments connect. This suggests that the cosmic web may be influencing galactic evolution in ways we don't yet fully understand. But filaments might be doing even more than shaping galaxies. They could be affecting the very nature of the universe's expansion. We know that the universe is expanding, and that this expansion is accelerating due to dark energy. But what if filaments are playing a hidden role in this process? Some theories suggest that filaments might act as a kind of cosmic tension, stretching and pulling on spacetime in ways that contribute to the acceleration of the universe. This could mean that filaments are not just structures within the universe. They might be active players in the cosmic story. If they interact with dark energy, then they could be affecting the ultimate fate of the cosmos. Could filaments be part of the reason why the universe's expansion is speeding up instead of slowing down? If so, then they might hold the key to understanding whether the universe will expand forever, collapse in on itself, or transition into something entirely new. Another intriguing possibility is that filaments might be influencing the distribution of black holes. We already know that supermassive black holes exist at the centers of galaxies, but there's growing evidence that smaller black holes might be hiding within filaments themselves. If this is true, then filaments could be acting as cosmic cradles for black hole formation, providing the dense environments needed to create these mysterious objects. Some researchers even speculate that filaments might be connected to primordial black holes, hypothetical black holes that formed in the very early universe. If primordial black holes exist, they could help explain dark matter, and filaments might be the key to finding them. If filaments contain hidden populations of black holes, then they could be influencing the structure of the universe in ways we haven't yet considered. And what if filaments are more than just channels for normal matter? Could they be acting as highways for unknown forms of energy? Some physicists have proposed that filaments might be carrying vast amounts of magnetic energy, shaping the large-scale magnetic fields that permeate the cosmos. If this is true, then filaments could be playing a hidden role in everything from star formation to cosmic ray acceleration. This idea opens the door to even more radical possibilities. Could filaments be connected to hidden dimensions of space-time? Some theories in modern physics, including string theory, suggest that extra dimensions might exist beyond the three we experience. If filaments interact with these hidden dimensions, then they might be gateways to new physics, clues to a deeper reality that we have yet to uncover. This could explain why filaments seem to influence cosmic structures on scales far larger than we would expect. If they are linked to extra-dimensional forces, then their gravitational effects might be stronger than we realize. This could help solve some of the biggest mysteries in cosmology, including why dark matter behaves the way it does and why the universe is structured the way it is. If filaments do interact with hidden dimensions, then they might also be connected to the concept of cosmic strings, hypothetical defects in spacetime that could have formed in the early universe. Cosmic strings, if they exist, would be unimaginably thin but incredibly dense, capable of warping spacetime around them. Some theories suggest that filaments and cosmic strings might be related, with filaments acting as large-scale manifestations of these hidden structures. If this is true, then filaments might not just be shaping the universe. They could be relics of the very fabric of reality itself. They might be imprints of processes that happen moments after the Big Bang, fossilized traces of fundamental forces that shape the cosmos in ways we still don't understand. And if filaments are connected to the early universe, then they could be windows into the past, natural observatories that hold clues to how the first structures formed. By studying filaments, we might be able to learn more about the physics of the Big Bang, the nature of dark matter, and the ultimate fate of the cosmos. But what if filaments are doing something even more profound? What if they are not just passive structures, but active components of the cosmic engine? Some researchers have suggested that filaments might be involved in feedback loops, cycling matter and energy between galaxies in ways that keep the universe evolving. If this is true, then filaments could be the hidden regulators of cosmic evolution, helping maintain the delicate balance that allows galaxies to grow and thrive. This idea raises even more questions. Could filaments be influencing the formation of life itself? If filaments control the flow of matter and energy in the universe, then they might be indirectly shaping the conditions that allow planets, stars, and even life to exist. If certain types of galaxies form along filaments, and if those galaxies are more likely to have habitable planets, then filaments might be one of the most important factors in determining where life can arise in the universe. In other words, cosmic filaments might not just be shaping the structure of space, they could be guiding the destiny of everything within it. If cosmic filaments are influencing the large-scale structure of the universe, regulating the formation of galaxies, and even playing a role in the expansion of space itself, then they might be one of the most fundamental components of the cosmos. But what if their influence goes even deeper? Could filaments be connected to the very nature of time? One of the most perplexing mysteries in modern physics is why time flows in one direction. In our everyday experience, time moves forward, things age, entropy increases, and events unfold in a linear fashion. But at the quantum level, the laws of physics don't necessarily require time to have a preferred direction. Some physicists have suggested that large-scale structures like cosmic filaments might be influencing time's arrow in ways we don't yet understand. If filaments are massive enough to shape the distribution of galaxies and dark matter, then they could also be influencing the way time unfolds in different regions of space. Could time flow differently along filaments compared to the vast voids between them? Some researchers believe that extreme gravitational environments, like those near black holes, might warp time in unexpected ways. If filaments contain hidden black holes or act as conduits for exotic forms of energy, then they might be subtly affecting the passage of time on a cosmic scale. This idea leads to another strange possibility. Could filaments be pathways for information transfer across the universe? Some theories propose that the structure of space-time itself might allow for information to be transmitted in ways that defy our current understanding of physics. If filaments are composed of dense strands of dark matter and dark energy, then they might act as cosmic highways for information, allowing galaxies to communicate over vast distances. This would be a revolutionary idea. It would mean that the universe isn't just a collection of isolated islands of matter, but a deeply interconnected web where information, energy, and possibly even the fabric of reality itself are in constant exchange. If filaments do serve this function, then they might be far more than passive structures. They could be the backbone of the universe's hidden communication system. And if filaments are facilitating information transfer, could they also be influencing the fundamental constants of physics? One of the biggest mysteries in cosmology is why the laws of physics appear to be so finely tuned for the existence of life. The strength of gravity, the charge of the electron, and the properties of fundamental particles all seem to be precisely calibrated in a way that allows stars, planets, and living beings to exist. Some scientists speculate that these constants might not be fixed, but could instead be influenced by the structure of the universe itself. If cosmic filaments are playing an active role in shaping the universe, then they might also be affecting these fundamental constants in subtle ways. Could different regions of space have slightly different physical laws depending on their relationship to filaments? If so, then this could explain some of the strange anomalies we observe in the cosmos, such as the mysterious differences in the distribution of dark matter or the unexplained variations in cosmic background radiation. This brings us to one of the most mind-bending possibilities of all. Could filaments be connected to the idea of multiple universes? Some versions of string theory and the multiverse hypothesis suggest that our universe might be just one of many, existing in a vast cosmic landscape of parallel realities. If filaments are influencing the fundamental structure of space-time, then they might also be connected to the boundaries between different universes. Could filaments be cosmic bridges between different regions of the multiverse? If so, then they might be more than just structural features of our own universe. They could be the stitching that holds together an entire network of parallel worlds. Some researchers have even speculated that certain high-energy events, such as gamma ray bursts or unexplained cosmic anomalies, might be signs of interactions between our universe and others. If filaments play a role in these interactions, then they might be the key to unlocking the secrets of the multiverse itself. And if filaments do connect different universes, then what does that mean for the nature of reality? Could advanced civilizations, if they exist, have already discovered ways to use filaments as gateways to other dimensions? If there are extraterrestrial intelligences out there, they might have long since learned how to harness the hidden power of the cosmic web, using it to travel vast distances or even communicate across different realms of existence. The more we study filaments, the more questions arise. Are they passive structures, or are they active agents shaping the fate of the universe? Do they influence the flow of time, the laws of physics, and the structure of space itself? Could they be hiding unknown forces, exotic matter, or even signs of other universes? What we do know is that cosmic filaments are far more than just massive strands of gas and dark matter. They are fundamental to the universe's structure, guiding the formation of galaxies, influencing cosmic evolution, and possibly even shaping the very nature of reality. The deeper we look, the more we realize that these hidden cosmic highways might hold the answers to some of the greatest mysteries of existence. If cosmic filaments are more than just structural elements of the universe, if they actively influence the flow of time, shape the laws of physics, and even hint at the presence of a multiverse, then what else could they be hiding? Could they contain exotic forms of matter or unknown energy sources that defy our current understanding of physics? One of the most perplexing aspects of filaments is their relationship with dark matter. We know that dark matter plays a critical role in shaping the universe, but we still don't know what it actually is. Most of the mass in filaments is thought to be composed of dark matter, yet despite decades of research, no one has been able to detect it directly. Could filaments be hiding an entirely new kind of particle or force that we haven't discovered yet? Some physicists speculate that filaments could be reservoirs of axions, hypothetical particles that might make up dark matter. Axions are predicted to be incredibly light and interact with normal matter in ways that are nearly impossible to detect. If filaments are rich in axions, they could be a key piece of the puzzle in solving the dark matter mystery. But what if the truth is even stranger? There are theories that dark matter might not be made of particles at all, but instead could be a manifestation of hidden dimensions or new forces of nature. Some versions of string theory suggest that additional dimensions of space could exist beyond the three we experience, and that dark matter might be leaking into our universe from these hidden realms. If filaments are concentrated regions of dark matter, could they also be intersections between our universe and these extra dimensions? This could explain why dark matter is so difficult to detect. It might not exist in our reality in the way ordinary matter does. Instead, it could be an echo of a deeper, hidden structure of space-time, and filaments might be the places where this hidden structure becomes most pronounced. If this is true, then studying filaments might not just teach us about dark matter, it might reveal the existence of entire new layers of reality. Filaments could also hold secrets about the mysterious force known as dark energy. While dark matter pulls galaxies together, dark energy is doing the opposite. It's driving the accelerated expansion of the universe. Strangely, filaments exist in a delicate balance between these two opposing forces. On one hand, they serve as gravitational highways, channeling matter into galaxy clusters. On the other hand, they are stretched and distorted by the expansion of space itself. Could filaments be more than just passive participants in this process? Some researchers think that filaments might actually be sources of dark energy, or at least play a role in its distribution across the universe. If filaments store unknown forms of energy, they might act as cosmic batteries, slowly releasing energy into the fabric of space over billions of years. This could explain why the expansion of the universe appears to be accelerating. Perhaps filaments are slowly feeding dark energy into space, driving galaxies apart faster and faster. But here's where things get even more bizarre. Some scientists have proposed that dark energy might not be a fundamental force at all, but rather a sign that our understanding of gravity is incomplete. Could filaments be the missing link in our theory of gravity? If the gravitational pull of filaments behaves in unexpected ways, then they might be evidence that gravity itself works differently on cosmic scales than we previously thought. This could have profound implications for our understanding of the universe. It might mean that what we call dark energy isn't an unknown force at all, but rather a sign that space-time behaves in ways we haven't yet discovered. Filaments, as the largest structures in the universe, might be the key to unlocking this mystery. If we can understand how gravity works within filaments, we might finally figure out why the universe is expanding the way it is. And if filaments are connected to the nature of gravity itself, could they also be connected to black holes? Black holes are some of the most mysterious objects in the universe, capable of warping space and time in ways that defy our intuition. Some researchers believe that supermassive black holes might actually form within filaments before migrating to the centers of galaxies. If this is true, then filaments might not just be shaping the structure of the universe, they might also be the birthplaces of the most extreme objects in existence. This raises an even more mind-bending possibility. Could filaments be cosmic-scale black holes themselves? While this idea sounds extreme, some physicists have speculated that vast regions of space might behave like black holes in ways we don't yet understand. If filaments contain exotic forms of matter or energy, they might warp space-time in ways that mimic the behavior of event horizons. Could filaments be trapping energy and information in ways we haven't realized? If so, then this might connect filaments to one of the biggest unsolved mysteries in physics, the holographic principle. The holographic principle suggests that the entire universe might function like a giant hologram, where all the information that makes up reality is actually encoded on a lower dimensional surface. Some scientists think that cosmic filaments could be places where this principle is most evident, acting as cosmic data storage systems that encode the fundamental structure of the universe. This would mean that filaments aren't just shaping galaxies and distributing matter, they might actually be encoding the rules that govern the universe itself. If the holographic principle is correct, then filaments could be the hard drives of the cosmos, storing the information that determines the behavior of everything from stars and planets to the fundamental forces of nature. But if filaments are information storage systems, could they also be manipulated? If an advanced civilization discovered how to access the data stored in filaments, they might be able to rewrite the laws of physics themselves. Imagine a species so advanced that they could alter the structure of reality by modifying the information encoded in filaments. If such civilizations exist, then they might have already learned how to manipulate the cosmic web to control space, time, and energy on an unimaginable scale. And if filaments are information networks, could they also be part of a vast cosmic intelligence? Some physicists and philosophers have speculated that the universe itself might be a form of intelligence, with complex structures like filaments acting as neural pathways. If this is the case, then filaments might not just be shaping the universe, they might be the universe thinking. This idea, known as panpsychism, suggests that consciousness might be a fundamental property of the universe itself. If filaments are massive information processing structures, then they could be playing a role in a kind of cosmic intelligence that we are only beginning to comprehend. Could the entire network of filaments be part of a vast, self-organizing system that operates on scales far beyond human understanding? If this is true, then filaments might not just be the skeleton of the universe, they might be its mind. The very structure of space could be a form of computation, with galaxies, dark matter, and even black holes acting as components in a vast cosmic machine. If we ever learn to decode the information stored in filaments, we might not just discover the secrets of the universe, we might discover that the universe itself is alive. The more we learn about cosmic filaments, the more mysterious they become. They are the hidden highways of the cosmos, the silent architects of galaxy formation, and possibly the key to understanding dark matter, dark energy, and even the nature of reality itself. Whether they are cosmic bridges, information networks, or even the neurons of a vast universal consciousness, one thing is certain: filaments are far more than just strands of gas and dust. They might hold the answers to the deepest questions humanity has ever asked. And as we continue to study them, we may come to realize that the universe isn't just a collection of objects moving through space. It's an interconnected web of forces, energies, and information, all bound together by the hidden structure of filaments. In unraveling their mysteries, we might not just learn more about the universe, we might finally understand our place within it. The implications of cosmic filaments stretch far beyond what we currently understand. If these vast, thread-like structures are indeed shaping the formation of galaxies, influencing dark matter distribution, and possibly even playing a role in dark energy's mysterious effects, then the question becomes, what else are they capable of? One possibility that has fascinated scientists and theorists alike is the idea that filaments could act as conduits for unknown forces or exotic matter. In some theories of modified gravity, the distribution of mass in filaments may not follow the standard laws of Newtonian physics, or even Einstein's general relativity. Instead, some researchers suggest that filaments could be regions where alternative forces, ones that only emerge on cosmic scales, become dominant. This raises a perplexing question: could filaments be influencing the very nature of time itself? If filaments contain high concentrations of dark matter and interact with the fabric of space in ways we don't yet fully grasp, then it's possible they could have measurable effects on time dilation. In extreme cases, time might flow differently near these structures compared to the vast voids between them. If that's true, it could mean that galaxies embedded within filaments experience time differently than those in isolated regions. Could this explain some of the anomalies observed in the way galaxies evolve? Some galaxies seem to age more rapidly than expected, while others appear strangely young despite existing in what should be an ancient part of the universe. If filaments subtly affect the passage of time, it might mean that different parts of the universe are evolving at slightly different rates. And if time isn't flowing uniformly across the cosmic web, could filaments also serve as natural accelerators for energy and particles? Some researchers have proposed that filaments act like cosmic highways, not just for matter, but for cosmic rays and other high-energy particles. These particles, traveling along filaments, might experience gravitational boosts that accelerate them to nearly the speed of light. This could have profound consequences for our understanding of high-energy astrophysics. Some of the most energetic cosmic rays ever detected have mysterious origins. They arrive on Earth from distant parts of the universe, but their sources are often difficult to pinpoint. Could filaments be launching these particles across intergalactic space, acting like giant particle accelerators stretching across millions of light years? If so, then filaments could be influencing the radiation environment of entire galaxies. High-energy cosmic rays can trigger the formation of new stars by ionizing gas clouds, or they can suppress star formation by heating up interstellar material and preventing it from collapsing. If filaments are channels for these powerful cosmic particles, they might be playing an unseen role in determining which galaxies become rich with new stars and which ones remain dormant. But the mysteries of filaments don't stop there. Another tantalizing idea is that filaments might be key to understanding the large-scale structure of the universe, not just in terms of matter, but in terms of fundamental physics itself. Some researchers have speculated that the patterns of filaments might encode information about the early universe, preserving subtle imprints from the Big Bang that we have yet to decipher. Could filaments hold clues about the initial conditions of the universe? If the cosmic web formed as a result of quantum fluctuations in the very first moments after the Big Bang, then filaments might contain relics of those primordial structures. By studying the exact distribution and alignment of filaments, physicists might be able to reconstruct aspects of the universe's earliest moments that are otherwise hidden from view. And if filaments are preserving information from the birth of the universe, could they also be influencing its ultimate fate? Some cosmologists believe that the evolution of the cosmic web might provide insights into how the universe will end. If filaments continue to stretch and thin out over billions of years, they might eventually dissolve, leading to a state where galaxies are no longer connected by these cosmic highways. This could accelerate the isolation of galaxies, making it even harder for matter to interact on cosmic scales. In a far future scenario, if filaments decay entirely, the universe might enter a phase where gravity loses its ability to pull new structures together. Could filaments be the glue holding the universe together? If they disappear, does the cosmic web itself unravel? And if the cosmic web unravels, does that mean the fundamental fabric of reality changes? Some researchers suggest that filaments could be linked to the underlying nature of space itself. If filaments influence the distribution of dark matter, dark energy, and even the behavior of gravity, then understanding them might be the key to unlocking a deeper theory of everything, a framework that unifies all forces of nature. One of the strangest possibilities is that filaments might be more than just structural components of the universe. They might be essential to its very existence. What if filaments aren't just shaping the cosmos, but are instead a fundamental feature of space-time itself? Some theories suggest that space-time could be emergent, meaning that what we perceive as space is actually a byproduct of deeper, more fundamental interactions. If this is true, then filaments might not just be structures within space. They might be part of the process that creates space. The cosmic web could be more than just a scaffolding for galaxies. It might be the actual mechanism through which the fabric of the universe forms and evolves. This would mean that filaments are not just influencing matter, but are actively shaping reality itself. And if filaments are responsible for structuring space, could they also be connected to the nature of consciousness? Some physicists and philosophers have speculated that the organization of the universe might have parallels to the structure of the human brain. Neurons in the brain form networks that transmit information, much like filaments connect galaxies. Could this resemblance be more than just a coincidence? If the universe has an underlying informational structure, then filaments might be playing a role similar to neural pathways. They might be responsible for transmitting information across vast distances, preserving the memory of cosmic history, or even participating in processes we don't yet understand. Could filaments be part of a cosmic intelligence that we have yet to recognize? This idea might seem far-fetched, but if the universe is governed by information as much as by matter and energy, then filaments could be much more than just strings of gas and dark matter. They could be the channels through which the fundamental rules of reality are written and rewritten over time. And if filaments do encode the laws of physics, could they also be changing over time? If filaments are dynamic structures, constantly shifting and evolving, then they might be altering the very nature of the universe as they change. Could the laws of physics themselves be different in different parts of the cosmic web? If filaments are regions where dark matter, dark energy, and gravity interact in unusual ways, could they be places where the constants of physics vary? If this is true, then exploring filaments might not just teach us about galaxy formation. It might reveal new laws of nature that only exist on the largest scales. The more we learn about these cosmic structures, the more they challenge our understanding of the universe. Filaments remain one of the greatest unsolved mysteries of cosmology, hinting at deeper layers of reality that we have yet to uncover. They might be the highways of galaxies, the birthplaces of dark matter, the generators of cosmic energy, and even the keys to understanding space-time itself. Whatever secrets they hold, one thing is certain: the deeper we look into the universe, the more we realize that everything is connected. And in unraveling the mysteries of filaments, we may finally come to understand the hidden architecture of the cosmos. If filaments are the hidden scaffolding of the universe, shaping the formation of galaxies and the flow of matter across cosmic distances, then the next question is, how exactly do they influence the life cycle of galaxies? The gravitational pull of these vast structures dictates where galaxies form, how they evolve, and even how they die. But their role is still one of the most overlooked mysteries in astrophysics. One of the most intriguing aspects of filaments is their role in galaxy clustering. Galaxies do not form randomly throughout the universe. They tend to group together along filaments, often appearing in long chains or at the intersections of multiple filaments where gravity pulls matter together most efficiently. These intersections are known as nodes, and they act as cosmic hubs where galaxies congregate. The formation of massive galaxy clusters often begins in these nodes, where dark matter concentrations are highest. But filaments do not just attract galaxies, they also feed them. Gas flows along these cosmic strands, funneling cold hydrogen into galaxies, which serves as the raw material for star formation. Without this steady inflow of gas from filaments, many galaxies would quickly run out of the fuel needed to create new stars, leading to an early death. This process, where galaxies drink from the filaments, explains why some galaxies remain active star-forming regions while others become quenched and stop forming stars altogether. When a galaxy remains connected to a filament, it can keep growing, forming new generations of stars over billions of years. But if it gets cut off from the filament, either by drifting too far away or by interactions with other galaxies, its star formation slows down and eventually ceases. Interestingly, some galaxies appear to be moving upstream, along filaments, drawn toward the densest regions by the pull of dark matter. These galaxies are being funneled into larger clusters, merging with other galaxies in the process. This means filaments are not just passive structures. They are actively shaping the growth of galaxies, directing their movements like invisible rivers flowing through the cosmos. But what happens when galaxies reach the end of a filament and fall into a massive galaxy cluster? This is where another mystery emerges. Galaxies that enter the high-density environment of a cluster often experience extreme changes. Some get stripped of their gas as they plunge into the cluster, losing their ability to form new stars. Others experience violent interactions, colliding with neighboring galaxies in a chaotic gravitational dance. Filaments act like conveyor belts, feeding galaxies into these dense environments where they are transformed, or even destroyed. This could explain why some clusters contain a large number of dead galaxies, elliptical galaxies that no longer form stars and appear to have had their gas removed. The journey along a filament might be a one-way trip, leading galaxies toward an inevitable fate in the heart of a galaxy cluster. But not all galaxies suffer this fate. Some remain in the quieter, less chaotic regions of filaments, where they can continue evolving on their own terms. These galaxies tend to be spiral galaxies, like our Milky Way, which retain their gas and keep forming stars for billions of years. This raises an interesting possibility. Could our own galaxy's position in the cosmic web have determined its fate? The Milky Way sits on the outskirts of the Virgo supercluster, a vast structure connected by filaments. While it is moving toward the larger structures of the cosmic web, it has not yet fallen into a massive galaxy cluster. This relative isolation may have protected it, allowing it to maintain its spiral structure and continue forming stars at a steady rate. If the Milky Way had formed deeper within a filament, or closer to a dense cluster, would it have turned into an elliptical galaxy long ago? Would the forces of the cosmic web have shaped it into something unrecognizable? This suggests that the location of a galaxy within the filaments of the cosmic web might be one of the most important factors in determining its evolution. And if filaments influence galaxy evolution, could they also be responsible for the existence of life itself? If galaxies and filaments receive a steady flow of gas and remain star-forming for longer periods, then they have a higher chance of forming habitable planets. In contrast, galaxies that get cut off from their filaments may become barren, unable to produce new stars and planetary systems. This leads to a fascinating question: could filaments create cosmic, Goldilocks zones, where conditions are just right for life to emerge? If filaments provide a stable environment for star formation, then they may also be influencing where habitable planets are most likely to form. The structure of the cosmic web might not just shape the distribution of galaxies. It could be shaping the distribution of life itself. But this idea raises even deeper questions. If filaments are crucial for galaxy formation and possibly for the emergence of life, then why do they exist in the first place? What mechanism led to their formation? Scientists believe filaments began to take shape shortly after the Big Bang, as tiny fluctuations in the density of the universe grew over time. These small variations, created by quantum effects in the early universe, were amplified by gravity, leading to the formation of the first filaments. But could there be another explanation? Some researchers speculate that filaments may be linked to fundamental properties of the universe that we do not yet understand. If dark matter plays a dominant role in shaping filaments, then uncovering their true nature could reveal secrets about the fundamental forces governing the cosmos. And if filaments are connected to dark matter, could they also be tied to dark energy? Dark energy is the mysterious force causing the expansion of the universe to accelerate, and it remains one of the greatest unsolved mysteries in physics. Some scientists have suggested that filaments might interact with dark energy in ways we do not yet comprehend. Could filaments be guiding the expansion of the universe, acting as cosmic highways not just for matter, but for the very structure of space-time? If so, then filaments might be playing a role in the fate of the universe itself. If they continue stretching and thinning over billions of years, will they eventually dissolve, leaving galaxies completely isolated? Could this process lead to a future where the universe becomes fragmented, with galaxies drifting apart until they can no longer interact? Or could filaments be revealing an even deeper truth about the nature of reality? Some physicists speculate that the structure of filaments might resemble the geometry of higher-dimensional space. If our universe is part of a larger, multidimensional reality, then filaments could be the visible imprint of a structure that extends beyond our three-dimensional perception. This raises the possibility that filaments are not just structures within space, but manifestations of something more fundamental. Could they be the cosmic equivalent of neural networks, transmitting information across the universe in ways we have yet to understand? If so, then the cosmic web might not just be a passive structure, it could be an active system, shaping the evolution of the universe in ways we have not yet imagined. Whatever the truth may be, one thing is clear: cosmic filaments are far more than just threads of gas and dark matter. They are the hidden engines of galaxy formation, the highways of cosmic evolution, and possibly even the key to understanding the deepest mysteries of the universe. The more we study them, the more they challenge our understanding of the cosmos. And in unraveling their secrets, we may finally come to understand the grand design of the universe itself. If cosmic filaments are the hidden scaffolding of the universe, shaping everything from galaxy evolution to the potential for life, then we must ask, what else might they be influencing? Could these vast structures hold clues about the fundamental forces of the universe? Could they be the missing key to understanding dark matter and dark energy? One of the most perplexing aspects of filaments is their sheer size. These structures stretch for hundreds of millions of light years, yet they are incredibly delicate compared to the dense galaxy clusters they connect. This raises an intriguing question: how do filaments remain stable over billions of years? If they are primarily made of dark matter, does that mean dark matter itself is structured in ways we have yet to understand? Current theories suggest that filaments are not static. They are dynamic, constantly evolving under the influence of gravity and cosmic expansion. Simulations of the early universe show that small density fluctuations in the primordial universe gradually grew into larger structures, forming the first filaments. But there is still a major gap in our understanding of how these filaments continue to grow, stretch, and influence galaxy formation over time. One possibility is that dark matter within filaments is not evenly distributed but instead exists in complex, web-like strands that mirror the overall structure of the universe. If this is true, it could mean that the true nature of dark matter is far more intricate than we previously thought. Instead of being a simple, uniform substance, dark matter may interact with itself in unexpected ways, forming filaments that act as invisible bridges between galaxies. This idea is supported by observations showing that galaxies and filaments appear to spin in coordinated ways, as if they are linked by an unseen force. Recent studies have found that galaxies along filaments often rotate in the same direction, suggesting that the influence of filaments extends beyond just gravity. They may also be imparting angular momentum to galaxies as they form. But how is this possible? If filaments are merely dense strands of gas and dark matter, why would they have any effect on the spin of galaxies? Some researchers believe that the answer lies in the early universe, when filaments first began forming. If dark matter was already structured into filaments before galaxies even existed, then these structures may have imprinted their rotational patterns onto the galaxies that later formed within them. This would mean that the large-scale structure of the universe is not just a random arrangement of matter but a deeply interconnected system, where the motion of one part influences the motion of another. And if filaments influence the spin of galaxies, could they also influence the movement of entire galaxy clusters? Some simulations suggest that galaxy clusters move along filaments like beads on a string, slowly being drawn toward the densest regions of the cosmic web. This motion could be driven by the gravitational pull of dark matter, but it could also be influenced by another, even more mysterious force: dark energy. Dark energy is thought to be responsible for the accelerating expansion of the universe, but its exact nature remains unknown. Some physicists have speculated that dark energy may not be evenly distributed throughout the universe but could instead be concentrated in certain regions, such as the empty voids between filaments. If this is true, then filaments could act as boundaries between different regions of dark energy, shaping the way the universe expands on a cosmic scale. This would mean that filaments are not just passive structures. They could be actively guiding the expansion of the universe, acting as cosmic highways that direct the flow of both matter and energy. If true, this could have profound implications for our understanding of the fate of the universe. Will filaments continue to stretch and thin out over time, eventually dissolving as the universe expands? Or will they remain as fundamental structures, shaping the cosmos for eternity? Some theories suggest that as the universe continues expanding, filaments will become weaker, and galaxies will drift further apart until they are completely isolated. If this happens, the cosmic web could eventually unravel, leading to a future where galaxies become stranded in an ever-expanding void. But other theories suggest a different fate. Some researchers believe that filaments could act as stabilizing structures, maintaining the connectivity of the universe even as it expands. If dark matter and dark energy interact in ways we do not yet understand, then filaments may continue guiding the motion of galaxies for billions of years to come. This raises an even deeper question. Could filaments be the key to understanding the true structure of space-time itself? Some physicists have proposed that the large-scale structure of the universe may resemble a higher-dimensional lattice, where filaments act as the visible traces of a deeper, multidimensional reality. If this is true, then the cosmic web may not just be a network of galaxies and dark matter. It could be a fundamental part of the fabric of the universe itself. If filaments are linked to the underlying structure of space-time, could they also play a role in the formation of black holes? Some theories suggest that supermassive black holes at the centers of galaxies may have formed within dense filaments, where matter was funneled into gravitational wells at an accelerated rate. If true, this could mean that filaments were not just responsible for forming galaxies. They may have also played a crucial role in the birth of the most extreme objects in the universe. And if filaments are connected to black holes, could they also be linked to another cosmic mystery, cosmic voids? These vast, empty regions of space contain very few galaxies and appear to be the opposite of filaments. But some researchers believe that voids and filaments may be two sides of the same coin. If filaments are regions where matter is concentrated, then voids may be regions where matter has been evacuated, creating an intricate balance between structure and emptiness. This could mean that the universe is not just randomly arranged but is governed by a deeper set of physical laws that dictate the formation of both filaments and voids. Some scientists have even proposed that voids may contain exotic forms of energy, or hidden particles that interact with filaments in ways we do not yet understand. Whatever the truth may be, one thing is clear: filaments are far more than just cosmic highways. They are the invisible backbone of the universe, shaping everything from the formation of galaxies to the expansion of space itself. And the more we study them, the more they challenge our understanding of the cosmos. Filaments may be the key to answering some of the biggest questions in physics. How did the universe take shape? What is the true nature of dark matter and dark energy? And could the cosmic web be revealing a deeper, hidden structure to reality that we have yet to uncover? The answers to these questions may still be hidden within the filaments themselves, waiting to be discovered. And as our understanding of the universe continues to grow, one thing is certain: the cosmic web is far more than just a network of galaxies. It may be the key to unlocking the deepest mysteries of existence itself. If filaments are responsible for organizing galaxies and guiding their evolution, then what else might they be controlling? Some researchers believe that filaments could play a role in determining the conditions necessary for planets, and perhaps even life, to form. This might sound far-fetched at first, but when we consider how interconnected everything in the universe is, it starts to make sense. One of the most fascinating discoveries in recent years is that galaxies inside filaments appear to be different from those found in isolated regions. Observations show that filament galaxies are more likely to be active, forming stars at a higher rate and containing more interstellar gas. This suggests that filaments may be acting as cosmic rivers, funneling fresh material into galaxies and fueling the formation of new stars and planetary systems. But here's where it gets even more intriguing. If filaments are shaping the environments of galaxies, then they could also be indirectly influencing the formation of habitable worlds. The distribution of heavy elements, such as carbon, oxygen, and iron, is crucial for planet formation, and these elements are produced in stars before being released into space. Since filaments help regulate the flow of matter in the universe, they may also be controlling where and how these elements are spread. This raises a mind-blowing possibility. Could the cosmic web itself be influencing the emergence of life? If filaments play a role in shaping the environments of galaxies, then they could be responsible for creating the conditions necessary for complex chemistry to take place. In other words, the large-scale structure of the universe might not just be a random arrangement of matter. It could be a framework that guides the development of life itself. This idea is supported by studies showing that galaxies and filaments tend to evolve differently from those in voids. While filament galaxies are rich in gas and heavy elements, galaxies and voids are often deprived of these crucial materials. This means that the distribution of cosmic filaments could be creating regions of the universe that are more or less favorable for life to arise. And if this is true, then it leads to an even bigger question. Could the cosmic web be the reason why intelligent life exists at all? If the structure of the universe is responsible for shaping galaxies, stars, and planets, then it may have also played a role in the emergence of civilizations capable of pondering these mysteries. Some scientists have even proposed that the cosmic web might contain subtle patterns that influence the development of advanced life. Could the arrangement of filaments determine where the most complex planetary systems form? Could it create pockets of the universe where civilizations are more likely to arise? And if so, could this explain why we haven't yet encountered extraterrestrial life? Because we are in a region of the cosmic web that is uniquely suited for intelligence to develop? While these ideas remain speculative, they point to a fundamental truth: filaments are not just passive structures. They are active, dynamic features of the universe that shape the cosmos in ways we are only beginning to understand. And yet there are still so many unanswered questions. If filaments are so important, then why don't we see them directly? The answer lies in the nature of dark matter, which makes up the majority of the cosmic web but does not emit light. Filaments are mostly invisible, detectable only through their gravitational effects on galaxies. But what if there is more to the story? Some researchers believe that filaments could be made of more than just dark matter and gas. There is a growing suspicion that exotic particles, perhaps even forms of matter we have never seen before, could be lurking within these vast cosmic highways. If true, then studying filaments might be the key to discovering new physics beyond what we currently understand. There is also the mystery of how filaments interact with black holes. Some of the most massive black holes in the universe are found at the intersections of filaments, where galaxies cluster together in enormous superstructures. Could filaments be feeding these black holes, funneling matter into them at an accelerated rate? And if so, could this explain why supermassive black holes grow so quickly in the early universe? Another bizarre possibility is that filaments could be linked to the formation of cosmic strings, hypothetical one-dimensional defects in spacetime that may have formed in the early universe. Some theories suggest that these cosmic strings could stretch across vast distances, influencing the motion of galaxies in ways we have yet to detect. If filaments are somehow connected to these structures, then they could hold clues about the fundamental nature of space and time itself. And then there's the biggest mystery of all: how do filaments fit into the larger story of the universe's fate? Right now, the universe is expanding, and galaxies are moving further apart. But what happens to the cosmic web as this expansion continues? Will filaments stretch and weaken over time, eventually disappearing as galaxies drift into isolation? Or will they remain intact, preserving the large-scale structure of the universe even as everything else fades away? Some theories suggest that filaments could play a crucial role in the long-term evolution of the cosmos. If dark energy continues to drive the expansion of the universe, then filaments may become stretched to the point where they can no longer hold galaxies together. If this happens, the cosmic web could eventually dissolve, leaving behind a universe where galaxies are so far apart that they can no longer interact. But other theories propose a different outcome. Some physicists believe that filaments could act as stabilizing structures, counteracting the effects of dark energy, and keeping the universe connected for eternity. If this is true, then the cosmic web may not just be a temporary feature of the universe. It could be a fundamental, permanent part of reality itself. And this brings us back to the biggest question of all: what is the true nature of the cosmic web? Is it simply a network of galaxies, or is it something more? Could it be the underlying structure of space-time? Could it be the key to understanding dark matter and dark energy? Or could it be something even more profound, an unseen framework that determines the very nature of existence? The truth is, we still don't have all the answers. But as we continue to study the cosmic web, one thing becomes clear: filaments are not just cosmic highways. They are the invisible threads that connect everything in the universe, shaping the cosmos in ways we are only beginning to understand. And perhaps, as our understanding of these structures deepens, we will finally unlock the secrets of the universe itself. If filaments are truly the scaffolding upon which galaxies form, then we have to ask, how did these vast structures come into existence in the first place? The answer lies in the very earliest moments of the universe, during the period immediately following the Big Bang. In the first fractions of a second after the Big Bang, the universe was a hot, dense soup of energy and fundamental particles. As it expanded and cooled, tiny fluctuations in the density of this cosmic soup began to form. These fluctuations, minuscule variations in temperature and matter density, were imprinted on the universe by quantum mechanics. They were random, but not entirely so. Some regions were just slightly denser than others, and because of gravity, those denser regions began attracting more and more matter over time. As the universe continued expanding, these small density variations grew into larger and larger structures. The densest regions became the seeds of galaxies, while the slightly less dense regions stretched into long, thin filaments. These filaments, made mostly of dark matter, acted as gravitational highways, pulling in normal matter, gas, dust, and eventually entire galaxies. Over billions of years, this process gave rise to the immense cosmic web we see today, with filaments stretching across hundreds of millions of light years, forming a vast network that connects everything in the cosmos. But while we understand the broad strokes of this process, many details remain a mystery. For example, why do some filaments appear thicker and more pronounced than others? Some models suggest that filaments might not just be passive structures but could have internal dynamics that we don't yet understand. There is even speculation that the interaction between filaments and dark energy, the mysterious force driving the accelerated expansion of the universe, could be influencing their shape and evolution. One of the biggest questions is how matter flows along filaments. Studies suggest that gas and even galaxies themselves move along these filaments like cars on a highway, slowly drifting toward the larger galaxy clusters at filament intersections. This movement is not random. It follows the gravitational pull of the filaments, guiding matter into specific patterns. But what's surprising is that this flow appears to be highly organized, with galaxies aligning themselves in ways that scientists didn't expect. Observations show that the rotation axes of galaxies tend to align with the direction of their parent filament. This means that filaments are not just passively holding galaxies, they are actively influencing how they spin and evolve. But how is this possible? Some researchers believe that as matter flows along filaments, it creates subtle forces that torque galaxies, gradually aligning them with the filament structure. If true, this would mean that filaments are playing a much deeper role in shaping galaxies than we ever imagined. This discovery also raises another question. If filaments can influence the orientation of galaxies, could they also be affecting the internal dynamics of galaxies themselves? Some scientists suspect that filaments might be responsible for triggering bursts of star formation in certain galaxies. When a galaxy moves through a dense filament, it might experience a rush of gas, which then collapses to form new stars. This could explain why some galaxies in filaments appear more active and vibrant than those in less dense regions. But what about the biggest structures in the universe, galaxy clusters and superclusters? These enormous formations, containing thousands of galaxies, sit at the intersections of filaments. They are the cosmic cities at the crossroads of the universe's highways. Could filaments be feeding these clusters, continuously funneling matter into them and keeping them growing over time? Recent studies suggest that this may be exactly what's happening. Observations of galaxy clusters show that vast streams of gas, sometimes stretching millions of light years, are flowing directly into them from surrounding filaments. This process is known as cold accretion, and it may be the primary way that galaxy clusters continue to grow. If true, then filaments are not just shaping individual galaxies, they are fueling the largest structures in the universe. And this brings us to another cosmic mystery, the role of dark matter in filaments. We know that filaments are primarily made of dark matter, but we still don't know exactly what dark matter is. Could studying filaments be the key to unlocking this long-standing mystery? One of the most promising ways to study dark matter in filaments is through gravitational lensing. Because dark matter has mass, it bends the light from distant galaxies behind it, distorting our view in predictable ways. By carefully analyzing these distortions, astronomers can map the distribution of dark matter within filaments. Recent gravitational lensing studies have confirmed that filaments do indeed contain vast amounts of dark matter, but there is something strange. Some filaments appear to have more dark matter than expected, while others seem to have less. Why would this be the case? Some scientists believe that filaments might be interacting with dark energy in ways we don't yet understand. If dark energy is pushing the universe apart, could it also be influencing the distribution of dark matter within filaments? This is one of the biggest open questions in cosmology, and answering it could change our understanding of both dark matter and dark energy. But here's where things get even stranger. Some theories suggest that filaments could be acting as bridges between different parts of the universe. Could filaments be tunnels through which matter and energy move in ways we don't yet comprehend? Could they even be connected to exotic physics beyond our current models? One particularly wild idea is that filaments could be linked to hidden dimensions of the universe. Some versions of string theory propose that extra dimensions exist beyond the three we experience in everyday life. If these extra dimensions are real, could filaments be somehow connected to them? Could they be channels through which energy moves between different layers of reality? While this remains highly speculative, it raises a fascinating possibility. What if filaments are more than just physical structures? What if they are fundamental components of the very fabric of the cosmos, influencing not just galaxies, but the underlying nature of space and time itself? And this brings us to the ultimate question: are filaments part of an even larger pattern? If we zoom out far enough, could the cosmic web itself be just one layer of an even grander structure? Some physicists suspect that our entire universe might be part of a vast, multi-layered reality, with filaments serving as the connective tissue between different levels of existence. If this is true, then understanding filaments might not just help us explain galaxy formation, it might help us unlock the deepest secrets of the universe. Could filaments be the missing link between our observable universe and hidden dimensions? Could they be the cosmic highways along which information, energy, or even entire realities travel? We don't have the answers yet, but what we do know is that filaments are far more important than we ever realized. They are not just the scaffolding of galaxies, they are the lifeblood of the universe itself, shaping everything we see in ways we are only beginning to comprehend. And as we continue to study these vast structures, we may one day discover that the cosmic web is more than just a pattern of matter. It may be a fundamental blueprint for reality itself. Let's dive even deeper into the implications of cosmic filaments and how they might be influencing the very nature of space, time, and the fundamental forces that govern the universe. One of the most intriguing aspects of filaments is their potential connection to the mysterious concept of cosmic strings. Cosmic strings are hypothetical one-dimensional defects in space-time, thought to have formed in the early universe. These ultra-thin but incredibly dense structures could stretch across vast distances, potentially aligning with the filamentary structure of the cosmic web. Some physicists theorize that if cosmic strings exist, they might be intertwined with filaments, acting as invisible conduits that shape the flow of matter in ways we don't yet understand. If filaments are connected to cosmic strings, this could have profound implications for our understanding of gravity. General relativity describes gravity as the warping of space-time caused by mass, but if filaments are influenced by underlying cosmic strings, they could be warping space-time in ways that challenge our current models. Could filaments be subtly bending the fabric of reality itself? Could their dark matter scaffolding be linked to exotic forms of matter or even undiscovered forces? To explore this, scientists have been using massive computer simulations to model the behavior of filaments on a cosmic scale. These simulations, such as the Illustris and Eagle projects, recreate the formation of the universe by simulating billions of particles of dark matter and normal matter, letting them evolve over billions of years. The results have been astonishing. Filaments not only guide the formation of galaxies but also appear to influence the motion of gas and stars at scales much larger than expected. One particularly strange discovery from these simulations is that filaments seem to form natural bridges between galaxy clusters. These bridges are not just thin strands of matter, they are complex, three-dimensional structures that contain swirling motions and intricate density variations. It's almost as if filaments are alive, actively shifting and flowing as the universe evolves. But what's even stranger is that some of these simulated filaments appear to have regions of negative mass, an exotic concept where matter would repel rather than attract. Could filaments be harboring strange forms of matter that interact with gravity in unexpected ways? The idea of negative mass may sound like science fiction, but some physicists believe it could be real. If certain regions of space contain negative mass, it would explain many of the strange gravitational effects we observe in the cosmos, including the accelerated expansion of the universe. Some even speculate that filaments could be the source of dark energy, the mysterious force that is pushing galaxies apart. Could the stretching and twisting of filaments be generating a repulsive force on a cosmic scale? This idea is still highly speculative, but it raises another fascinating possibility. What if filaments are not just structures, but processes? Instead of being passive highways for galaxies, could they be dynamic systems that generate energy, transfer momentum, or even alter the fundamental laws of physics over time? To test these ideas, astronomers have begun searching for signals of unusual physics within filaments. One of the most promising methods is through fast radio bursts, FRBs, brief, intense flashes of radio waves that originate from deep space. Some researchers believe that these mysterious bursts might be linked to cosmic filaments, either as a result of energy being funneled along them or because of unknown interactions occurring within their structure. If we can pinpoint the exact locations of FRBs and compare them with known filaments, we might uncover new clues about the hidden physics at work in the cosmic web. And this brings us to another mind-bending question. Could filaments themselves be acting as cosmic antennas? If filaments are stretched across vast distances, filled with charged particles and magnetic fields, they might be capable of channeling electromagnetic energy in ways we don't yet understand. Some researchers have even suggested that filaments could be amplifying cosmic signals, making them detectable across billions of light years. If true, this could mean that filaments are not just shaping the universe physically, but also acting as conduits for information on a grand scale. If filaments can transmit energy or information, then we have to ask, could they be used for communication? Could an advanced civilization, one capable of manipulating cosmic-scale structures, use filaments as a means of sending signals across the universe? This idea, known as the galactic internet hypothesis, suggests that if intelligent life exists elsewhere, it might be utilizing filaments as natural highways for interstellar communication. While this remains purely speculative, it opens the door to an even more profound idea. What if filaments themselves are a form of intelligence? Could the universe's structure be shaped not just by random physical processes, but by some underlying principle of self-organization that we have yet to recognize? If filaments are guiding the formation of galaxies, influencing the flow of matter, and possibly even interacting with exotic physics, then they may be far more than just cosmic scaffolding. They could be the fundamental organizing principle of the universe, a hidden architecture that connects everything in ways we are only beginning to comprehend. And as we continue to study them, we may one day discover that the filaments stretching across the cosmos are not just passive structures, but active participants in the grand story of existence itself. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.